Major Dumb. Come in from your room. We've checked the feeds, we've checked the memes. This launch is a cartoon. Flurf control to Major Dumb. Your rocket's just a balloon. They filmed you in a warehouse. There's no rocket ship, there's no big plume. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is Major Dumb to Flurf control. I'm strapped in, feel the shake. The tower falls away from me. You can't fake this quake. Major Dumb to Flurf control. I'm way above your room, rising through the blue so fast it turns to velvet soon. You say it's all projection, but the windows say you're wrong. I'm floating past your story, and it's been wrong all along. Major Dumb, our charts all show you splashed into the sea. They dropped a capsule from a plane. You're still on Odyssey. Flurf control. I hate to break it, your script is out of date. The engines burned, the boosters turned. I watch the coastline fade. You talk about a snow globe sky, a ceiling painted cold, but I just watched horizons curve in every shade of gold. Major Dumb to Flurf control. The world's a swirling sphere. Clouds wrap round in lazy bands from pole to stratosphere. You say it's just a clever CGI veneer, but your world's become an island, and it's really, really small from here. You said there is a crystal shell, a cover hard and bright. I'm flying where your ceiling sits, yet nothing blocks the light. No glass, no grid, no glowing dome, just darkness deep and clear. Your dome was in your browser tabs, not hanging over here. Flurf control to Major Dumb. Our live chat says the pictures are all lies. Agencies just sell us tales, they're demons in disguise. Major Dumb to Flurf control. Your fears are getting loud, but I'm looking at an ocean that wraps behind a cloud. If stories had you cornered, I'm not here to shout you down, just asking you to tilt your head and spin that view around. Major Dumb to Flurf control. I'm circling slow and clear. I see the night chase after day around this shining sphere. You swore there'd be an edge, a wall where colors stop, but every orbit proves you wrong. We're living on a drop. Flurf control to Major Dumb. Your signal's getting thin. If space is real, if globe is true, where do our stories spin? This is Major Dumb to Flurf control. I'll bring you souvenirs around Blue Earth in every shot, and maybe calm your fears. Flurf control to Major Dumb. Flurf control to Major Dumb. Are you there?
Well, hello, everybody. Welcome to a beautiful Tuesday evening. Yeah, close enough. I am Dano. This is Unfornicated. Welcome if you're new here. If you're not new here, well, nice to see you all the same. Um, it's been a minute. We've had a lot going on. I'm not gonna lie, and apparently you guys have had a lot going on here in chat while waiting for me. So I appreciate that. So we'll run through these one at a time. We have Tori Hanzo, member for 6 months. Oh look, I can do this thing. Followed by Jim Daniels, says, we can do a thing. Followed by Geek, says, yes, we can. Followed by Holy Hand Grenade, oh, I can do this thing too. So everyone was there for 6 months. Holy Hand Grenade's there for 1 month. Thank you all for supporting the channel. I greatly appreciate it. Am I in a stadium? No. Why? Is the audio really shit? Hold up. Find. No, I should be all set to go. Yeah, Mike wasn't muted. Something else will mess up. Oh, and Stop the Stupidity pops his head in to go ahead and gift 5 unfornicated gift memberships. Thank you, bud. I greatly appreciate it. Don't know who those are going to go to yet because it's waiting. Oh, there we go. Binge Sneaker, Nick N, John's Cars and Stuff, Mark E from Austin, I'm guessing Australia. And there's going to be one more. It's not great, but it's not Roger bad. Okay, well, it's supposed to be on Studio Voice. So hold up. Maybe if I turn up the gain a little bit, it'll do this. So let's see. All right, I went ahead and checked some noise gates and stuff like that. Does that make it a little better? Gravity Pen just joined as a prefect. Gravity Pen, thank you, and welcome to the Infornati. That's better? Okay, great. Yeah, I had to update almost everything before going live. Broadcast, OBS, a few other things, because, you know, there's always an update somewhere along the line. Tori Enzo and his talk dirty to me, and I'll judge if it's better or not. Wow. Yeah, it's been a minute. Because to be perfectly honest, it's got a lot of stuff going on today on the channel. And it's not necessarily stuff that you're going to see directly on the channel, but you'll see the byproducts on the channel. That makes sense. So we had the Lowell Folk Festival, then we had the recap, then I've had work, then I've had dad duty, both of which I thoroughly enjoy because they keep me sane from doing all this mess. The other thing we had going on is, Mike from the Drunk the Bunk show and I did a thing. I'm sure you're all aware of that. We went to Stamford, Connecticut to go meet up with Flat Earth Dave. And the beautiful thing about that is I got it all recorded. And I let him talk and talk and talk for the better part of an hour. And yeah, he's got a lot to say. But it's all pretty low on evidence, though. So I don't know what to make of that. I don't know. We'll see. But we got a bunch of other things to talk about tonight. We're going to talk about a little bit about Sonar because some flirts on TikTok, people like Soli and stuff like that have been saying things like this. Dave also says something about Sonar and how far it goes. You know, one other variation of we see too far. We're going to do a little bit more about radar today because, well, Roger said some stupid shit. So we're going to go ahead and do that as well. What did you guys do? Sorry, I'm reading. Someone sent me a Discord message. I'm going to have to get some sort of context on that. I'm way behind on Discord messages. I do apologize. I have to sneeze. Hold on. Okay, great. There we go. So we're going to discuss Sonar. the SOFAR channel. We're going to talk about some of the science behind it. We're also going to talk about radar and some of the science behind that, because apparently the new British radar system called SAMPSON has done something no other radar has done. It has proved the Earth flat, according to Roger. So we're going to take a look at that. What else are we going to talk about tonight? We're going to talk a little bit about the Flat Earth meetup and some of the stupid shit that was said there. And we're also going to talk about what I have coming up in a couple of weeks. So stick around for that, because basically it's going to be, we're going to be reviewing some of the experiments I'm going to be doing while I'm down there. But I want input from you. I want you guys to tell me where I'm wrong, where I could do better. Maybe you have a better idea entirely. We'll figure it out. And that's the beautiful part about it. We can always figure it out. And one thing I learned with this group is that if there is a group that's going to figure it out, it is going to be this one. So let me just resize some windows here because I can't see shit, which kind of no surprise. No, don't do that. Just dock over there. Thank you. All right. Sorry, I misplaced something because that's what I do. See, look, audio is fine, but I'm gonna fucking start missing places of where I put things. So, hey, such is life. Oh, that's what I need. Hold up. Okay, so we're gonna move this over here. I gotta move my camera controls around. I'm close enough in the center. Oh, I know what's a problem. We need a light. Oh, holy shit. Hold up. It's a little overexposed. Let's knock that down a little bit because that's pretty ridiculous. Holy shit. Okay. There we go. Don't need to blind you all. Dropped a DM to... Okay, hold up. Oh, okay. No problem, Tori. Yes, thank you very much for that. I appreciate that. Yes, Holy Hand Grenade. He had a lot of words to say, but not actually anything to say. Go figure. So, here's the thing. I rather enjoyed Stanford. Guilty pleasure. Just like I kind of enjoy Rub. You kind of both get drunk on stupidity. And, but I will say the Flat Earth meetup had a longer hangover than Rum has because, wow. No big fish. We are Rum. Oh, what are we drinking tonight? Well, we are drinking Bumbu spiced rum tonight. Not affiliated nor sponsored. However, highly recommend. It is, it just says from the Caribbean. Oh, Barbados. Okay. So a little Bajan rum to go for the night, which is great. Maybe we'll play some Calypso music in the background and let it go. But let's start off with what kind of stupid shit we're going to talk about tonight. Let's see. I need to find, hold on. I was doing a search for something and I need to find it. Hold on. Let's, I need to search one thing because it's something I wanted to bring up for the SAMPSON radar. No, that's not, no, that's not it. That, oh, Jesus Christ, stop. Okay. Let's see if this helps. Maybe. No, I don't want to buy this. Can I get the... Holy shit. I do not want to buy the actual thing here. I gotta wait for the download. Okay. So we'll wait for that to download and I'll just check on that in a minute. So we have the typical zoo crew members here. I see basically everybody's in here. YouTube is slurping. Yeah, it apparently is. The stupidity. Oh, you know what? Hold on. You haven't been here near enough. Holy crap. Hold on. Why is YouTube being so dumb? There we go. Oh, Geek just dropped 10 memberships for the Unfornati. Thank you, Geek. I greatly appreciate that. You are a hero and a scholar. These went to, well, everybody here on the screen. Deplorable got one. That's always a good. Let's see. There's a couple other people in here. Citizen 9, Toe Fungus. Hackerman got one. Even better. Oh, look at that. You guys are supporting the channel tonight. I greatly appreciate it. Oh, I know what it was. I did a thing. I did a little coding that I haven't really done in fucking decades. But thanks to some proofreading AI, I was able to sort out where I misplaced a colon. So, yeah, look, trying to plot things out using a 3D model when you're not used to doing it and you haven't done it in a while, it's pretty brutal. But luckily, Holy Hand Grenade's here down there in the chat, and he's going to show some things. I'm going to show some things tonight. He's going to critique him and help me figure out where the F they went wrong. So, I don't know. Should we start with that? Let's start with that. The reason why I say we start with that is because if you have watched Whatcast recently, wow, I even had a calendar up. Calculator up. I must have been doing some math. Even if you've done, if you watch some Whatcast and things like that, there are, I need to change some things here. Hold on a second. And then I need to, okay, so I did some coding and I reached out to some people in our community. And what we did is I asked them for some, what's the word I'm looking for? I asked them for some information. I basically asked them to dox themselves. Now, these three specific people that I was asking for was because they had something very much in line with things that I do. So if you watched Whatcast in the last 2 weeks, you noticed I was talking about the GOES satellite. The GOES satellite is a weather satellite. It was put up by NOAA, and it sits at roughly 72 degrees west longitude, and coincidentally, because geostationary, directly over the equator. Now, these three people were actually pretty, they're pretty knowledgeable in things like satellites. They have a radio background. They have things that I don't have, namely a different location. Now, why would we need that? Well, I'm sure you're wondering. So let me transition this over and let me show you some things. All right, here's what we have. So we have 4 locations. We have Bermuda, Ohio Valley, and San Jose, and New York. Okay, pretty cool, right? We'll even zoom in a little bit here. Now, the funny thing is I had everybody tell me what their azimuth and elevation were to the satellite. Where did they point their dishes? Now, for GOES satellite, the way it transmits is you have to be pretty spot on. Now, it's not a pencil beam, so there's some little variations you can play with there, and that kind of cascades further. However, these 4 locations provides us with a nice little thing. Now, I'd love to have a Southern Hemisphere station that could point this out. But what I decided to do is I was like, let's start with 2D measurements. Tell me what your azimuth was, and let's find out where they all go to. So, looked at all their azimuths and everything else. Now, this is the prediction. The prediction says it's located right here. Okay? God, I still got to sneeze. Now, I don't have all the azimuths up and elevations up because you can use those to backtrack where people are located. And I don't want to dox anybody, nor do I want to dox myself. However, the beautiful thing is anybody can do this. Spend some money. Get an SDR, get a laptop, get some cables, get an associated antenna, point it up, and voila, goes from there. So this right here is the predicted location. So then I took everyone's measurements and found that we were a little off. Not much, but we were a little off. We're off by a total of about 200 kilometers. Not bad. Not bad at all. But the question is, where does this go on flat Earth? Well, it's funny you should ask. Let's look. Oh, well, this is a bit tangled. Let's see. One crosses, so two cross here, two more cross here, two more cross here. I'm sorry, here, let me do this. Two cross there, two cross there, two cross there, two more cross here. Oh, shit. They really don't cross anywhere where all four can see it at the same time. Huh. That's odd. But I tell you what. Let's actually go to a 3D model. Hey, Copium Emporium is just dropped $5 dues. Not Kiwi bucks, Aussie bucks, koala bucks. There we go. What level of derp are we dealing with today? We are dealing with a high level of derp because it's going to include Flat Earth Dave. So, yeah, there we are. All right, am I all caught up? Cool. So, yeah, this is wizardry by all means. But you know what? I'm sure that maybe if we apply a 3D model in this, it's going to clean it up a little better, make it look a lot more impressive and shit, right? Oh, no. Oh, no. Oh, no. Oh, no. Oh, shit. Ugh. Wow, those don't really point anywhere. Now, I was able to put a mathematical equation in this that basically says, where is the closest that all four of these come into, and what would be the elevation? The elevation is basically, I don't know if you can see it in here, is 4,795 kilometers high. However, at its closest for all four beams on a flat Earth, this is still 2,209 kilometers. I don't have my reading glasses on. Off. But hey, you know what? We don't know what's up in the sky. It could be a balloon. It could be anything, right? We don't actually know what's going on. I mean, it'd be weird if like all of a sudden things just started lining up and they all pointed to a, oh shit, single point in space. Huh. Single point in space that they all trace back to. Well, let's kind of zoom in here and take a look at what we got. Now, what we got here is four little cones. Now, the cones are cones of uncertainty. These are like directional errors. You say your azimuth is this, and you're basing it off doing some math or finding true north and versus magnetic north and doing the math, and you're off a couple places. So there's like, let's call it a half a degree of fudge factor of like, I don't, this might be a little off. Now, all four cones are different things. And if you notice, all four cones have this little white dot in the middle. And that little white dot has an altitude of 35,230 kilometers. Our maximum missed distance is about 128 kilometers. I think that's pretty damn good on math. But what's the projected? The predicted model. Well, the predicted model tells us we should be at, there we go, 35,786. So we were off by, when you do the math, we're off by 0.17 degrees longitude. So 4 people from the Atlantic Ocean to the west coast of the United States. are all pointing at the exact same antenna. Now, I could design this to where all four sites download the exact same weather map from the exact same antenna at the exact same time. That's 4 different time zones spread over 3,500 kilometers or more and 4 hours of difference. Here's the thing. If a flirt was come in here and give $50, I'll coordinate that so I can give money to the other 3 stations for their time. And I'll actually give them an extra $10, so that way it's $20 a person to do this for me. What are we gonna do? Because if I do that, they're just gonna say, "Nuh-uh." So why am I gonna coordinate it? So I asked them, "Have you done this recently?" The answer was yes. Have you done what can you tell me what your azimuth and elevations and approximate location was? Again, don't want them to dox with the exact GPS coordinates. This is what we have. So somebody somewhere has to explain why all these go out to this distance. They all receive the same signal, the same maps, the same antenna, the same everything, and it's this distant. How is it a weather balloon? Because if it was a weather balloon, you'd need 4 of them, all transmitting on the same frequency, all competing with each other, all at different elevations, all at different heights, and everything else. And oh yeah, this is available. It's geostationary, so it's available 24 hours a day, 365 days a year, regardless. So, how's that work? Yep. Thank you very much. So yeah, I don't do the falsification without, without replacement because that's a fucking cop out. I just falsified your fucking model, and I did it just using math and asking some friends. So maybe you guys should try it. But I digress. Yeah, I don't even subscribe to AE map, bro. Yeah, that's fine. Tell me what you subscribe to. Maybe this isn't exact. Great. I don't care how unexact it is. It doesn't work. So, if it's not your map, show me your map. Show me where 4 sites, one in Bermuda, one in San Jose, one in the Ohio Valley, and one in New York, can all see a stationary satellite and download from it, and the distance to that satellite matches our azimuth and elevations. Because again, I didn't tell them it was for this. I just said, hey, out of curiosity, what is your azimuth and elevation to the GOES 19 satellite? Oh, easy. Hold on. Let me find it for you. Here you go. He had no idea I was doing this shit. But when I told him I was doing this shit after they sent it to me, I said, don't worry. I'm going to cut off the screen. There's going to be no GPS coordinates shown, no actual values of azimuth and elevation and stuff like that, because an enterprising flirt could backtrack that. And I don't want to dox anybody. But it's all there. And that, my friends, is how you debunk flat Earth. Public holiday in the Australian world, that's perfect. Holy hand grenade, nut to the That sounds like that should be a song. That actually needs to be a song. All right, holy hand grenade. I'm gonna have stuff to do tonight. All right, enough of this horsing around shit. Let's talk about physics. There is something that's making me sneeze today. I have no idea what it is. I had the same problem last night too. All right, let's transition this so I can get to the next tab. What's the next tab? I'm not a robot. Hold on. Oh, I got to finish downloading this. Download the file. Come on. Come on. Come on. Come on. Come on. Come on. Download it. Go back in queue because I was talking so long. All right, whatever. Oh, perfect. Here we go. Download. UK meets. There we go. Let's pull that back over here out of the way. We'll get rid of, oh no, I need to look at this. Do. Am I dropping a shit ton? No, I'm not dropping frames. Why is this doing this? This. Don't want that one. Maybe I want this one. Holy crap. This is, oh, Jesus Christ. That's shit. Let's look at this one. Oh, no, that's the one I want. Hold on. Stop. That gives me the download. Thank you very much. That's what I wanted. All right, cool. Perfect. There we go. Okay. Where does this go? This goes in over here. And then we have that, and we have this, and we have this. Okay, so you go over here. Okay. So let's talk a little bit about life, shall we? One of the things that we know about, well, physics and science is that there was a point that there was 300-pound bombs that were dropped. Maybe it was 5. I don't remember. It was 1 to 2, 3 or 5. That was dropped off of Perth right over here. So if you're looking, see where the circle? Oh, whoops. Hold on. I can go back to what I was doing. Hold on. Let me fix my screen real quick here. Bear with me for 1 second. Let's just do. Let's bring that back up. And then let's open that tab a little bit. And there we go. Cool. All right. There we go. Fade it and shift it over. There we go. Okay. So we have Perth. Perth is this circle down here. You see this? Yeah. All right. So off the coast of Perth, like right around here, they dropped some bombs. And the story goes that it was received in Bermuda, which is located right here. Now, why did that happen? Well, that's an open question. So, I got to get my notes here because I kind of went a little out of order. And I know Nick N, if he's here, great. If he's not, he asked me a question on Max's live stream yesterday that I will get to today. So let's call this the shot heard around the ocean. Okay. So the HMAS Diamanthia, which is an Australian Navy boat. Here, I'll do you one better here. I know you guys like pictures. There we go. This ship right here, K377. It went off the coast of Western Australia, right around near Perth. It dropped 3 surplus 300-pound depth charges. They were separated by about 5.5 minutes apiece, and they were heard in Bermuda's hydrophone station. And there's records that correspond to this. Now, the interesting thing was it took 3 hours and 43 minutes later because where Perth was located and where Bermuda is located is separated by 19,820 kilometers, or roughly 170, I think 176 degrees, nearly antipodal. So, because of that, The sound went down, around, came around, and went up to Bermuda. How did that happen? Well, when they did this in 1950, 1960, there was some questions as far as the physics and things like that. And there wasn't a lot of supercomputers lying around to model some stuff because you use math to model things. So what they did is they started taking a look at it. So this does not mean it was one acoustic ray that just bent around just around Africa, just whatever. I mean, there's sound is open to things like refraction, reflection, diffraction, things like that. So to create something from 60 years ago plus, 70 years ago plus, it's a little difficult to do that. However, we have science that can actually do things like model things and look at things and tell us possibly how this occurred. But there are some things that aren't up for debate. There's some things that are factually known. The first is that the ocean is not acoustically homogeneous. Okay. Sound speed is primarily changes with temperature, salinity, and pressure. So near the surface, temperature dominates. Then you get what we call a thermocline. Then beneath that, as the temperature drops, the sound of speed generally drops with it. At greater depth, the temperature stabilizes, but then pressure goes up. And then when pressure goes up, the sound speed goes up. And eventually you get a sound speed minimum. Okay. So basically what happens is you have the sun heating up the ocean. It creates a thermocline at the bottom. If you've ever been a scuba diver and seen a thermocline, it's actually really cool. It almost looks like a shimmer on above you. And you can actually take your hand and stick it through the thermocline, and you will see more or less what equates to a mirage across your hand as you're looking at it. And it's probably close to a 10, 15 degree difference. If you're not a scuba diver, I'm sorry. You lead a boring life and should get hobbies. So you have a thermocline at the top. You have this SOFAR channel in the middle, and then you have a bottom channel underneath. So the pressure at the bottom creates a reflective surface. The thermocline at the top creates a reflective surface. Now, why are these three layers important? Well, for a submarine, it's for them to hide. If they're in the thermocline, that means they're close to the surface. When they're close to the surface, airborne targets and ships can hear them and see them. If you're chasing said submarine, the submarine dives. His point is to get below the thermocline as quickly as possible. Now, I'm not going to go into things like cavitation and things like that happens on a submarine that causes noises and everything else to show up on a sonar. However, for them to be detected on a sonar itself, let's just say just sitting, resting in the middle of the ocean, if they're below the thermocline, it's not that they cannot be detected, but they're less likely to be detected because things happen like angle of incidence and also the frequency and things like that all add up to variables as to whether or not they can break through that thermocline. And even when it breaks through the thermocline, how much energy is still available to bounce off an object and return back to the ship to get a fix. Now, if you're in that channel and you send out sonar, think sub to sub, it's going to bounce off the thermocline and it's going to bounce off the pressure plate in the below. So if you are another sub hiding from another sub, you either go up or you go down. Because again, that barrier prevents that sonar from having a direct, quote unquote, like line of sight to you. This is just simple submarine tactics. Now, whales and everything else and what we call biologics are in that SOFAR channel. This is why a blue whale can be heard thousands of kilometers away. American talking kilometers, is something sus here. Yes, there is something sus. So, what is this channel, the SOFAR channel in the middle? Well, what happens is, hold on. You guys have seen me use this before. I'm going to use it again. I need to find my thing here. What happens is these two layers present what we call waveguide. Now, we've talked about waveguides before, and I've even shown you a physical representation. This is a waveguide, okay? Now, this is total reflection, but you understand kind of like this is just gives you like more of a visual as what to kind of think about it as. You have light that is going around a really tight circle because it's being reflected all the way around and things like this. So a waveguide has one refractive property that it rides, and it has the different changes outside of that reflects signal. In this case, it's sound, not light. Same pretense in that the sense that this channel and these temperatures create a waveguide, a duct, just like the tropospheric ducting we talked about with LoRaWAN. But like a tropospheric duct, it's not homogeneous. It's the equivalent of riding a skateboard down a sidewalk in downtown Boston. So you have cracks that are all over the sidewalks. You have dips, for entryways, for driveways and things like that. You have cobblestones that get in the way. All this, all this stuff that makes it to where it's not a straight line where everything's all nice and neat like a freeway and just so happens to have an off-ramp. No, it's none of this. Now, what happened is that they were able to get. Oh, so hold on, let me bring this up real quick. So this is a Navy training about sonar. So this is chapter 16 about sonar, harbor defense, and other sonar systems. So it talks specifically about a sound channel that's formed in a layer of water that has negative velocity gradient overlaying an adjacent layer that has a positive velocity gradient. Under these conditions, any sound signal that originates at a depth above or below which there's a higher velocity is refracted back and forth. So remember, as pressure goes up, speed goes up. As temperature goes down, or as temperature goes up, speed goes up. So in the middle there is where it sits. So it becomes horizontally channeled. So sound rays originating with an initial upward inclination are reflected downward, and those originating with an initial downward inclination are reflected upward. Now, again, so you think of this as like a three-layer cake. If you're in this channel, it's not like you can't break out of this channel, it's just difficult. So if you're in the top channel, you're kind of confined within the top channel. You can break out of it. Well, you can't really use sonar in the air, but you understand what I mean. You can break down below it to the next layer. However, it takes a lot of energy. It takes a lot of different variables that has to be accounted for. When you're in the middle layer, you're kind of safe in that middle layer as long as it's in the middle layer, unless somebody looking for you is in the middle layer, because it's going to refract between those two. And if you're in the bottom layer, that's where the bottom layer is. So again, you can cross these layers. You can cross the streams, so to speak, but it requires a lot of power. It requires specific angles of incidence, and it varies greatly based on temperature, salinity, pressure, things like that. These are all variables you have to account for, which no one does. Well, let me rephrase that. No one on the flat earth side does. So this is known. This is, without a shadow of doubt, this is what's there. We know that this happens. Flat earth can't be, cannot do their own research and or did their own research, saw what this said and like, maybe it's not a proof after all, and then pretend that they never saw it. So as a result of the channeling, the signal intensity is not subject to attenuation resulting from normal spreading because the spread is confined primarily in the horizontal plane and not the vertical plane, just like tropospheric ducting. Again, this is a waveguide. Now, the difference is that when we talk about a waveguide being like a piece of fiber, this is cylindrical, so therefore it keeps everything cylindrical. But when we're talking about the Earth, we're talking about, everything separates it horizontally and prevents it from going vertically. Great. What does all this fucking mean? Well, what this means is simple. Is we have papers. You know me, we have papers. So originally, and I'm going to, oops. Oh, no, not that. Hold up. Stop it. Okay. So, from the Journal of Physical Oceanography, this is from 1960, written by Monk, O'Reilly, and Reed. Now, this is from the Scripps Institute, which happens to be in San Diego, my home turf. Great little aquarium. Also happens to be located near some of the best diving spots in the world. However, you cannot take anything from there because it's a protected area. Thank you very much. And don't get me started on the fact that I swear to God, lobsters can read a map and know when they're protected and when they're not, because they all sit in that protected area and wave at you, and you can't find any out here. That's just the way it is. So by the way, guys, tag me on anything if you want me to, if you have questions anywhere along the line, or if you want me to stop and expand upon something, or if any derpling wants to come on up, I will give you a Zoom link and you are happy to explain this shit in your paradigm. Anyway, back to what it is. So this is from 1988. So 1988, am I on the right screen? Yes. Am I? Yeah. Okay, cool. So detonations at the sound of a sound channel axis off Perth, Australia, is recording them in Bermuda hydrophones at 178.2 degrees, nearly antipodal. The analysis by Shockey and all of this 1960 transmission, because Shockley was the first one to actually look into this. I got to get my notes again. So when Shockley looked at this, they said that there's some other mechanism. I forgot exactly what it was, but here's the point that matters. That's most important here is that Shockley was wrong. And this paper is one of the ones that said, here's what's possibly right. So the analysis of Shockey and his 1960 transmission experiment allows for the geographic variation in the sound speed profile along the Great Circle Path. The agreement between measured and computed travel times is within 10 seconds. Everyone's happy. We have modified Shockey analysis to by allowing for Earth flattening and lateral refraction. Why would they do Earth flattening? I don't know. Let's talk about it. The appropriate path on an ellipsoidal Earth, is the geodesic, and this differs significantly from the Great Circle from the nearly antipodal ranges. Now, remember that we're going to come back to this in a second, and I'll show you why. So there remains a question. Oh, I'm sorry. We find that a scattered path just rounding the tip of Africa, thus consisting of one refracted ray from Perth to Cape Agulhas, and another ray from that cape to Bermuda with a 3-degree kink, has a travel time within a few seconds of the measured travel time, 3,372 seconds. There remains the question of how enough acoustic energy gets into the shadow zone to account for the measured intensity at Bermuda, which is poorly known. Diffraction is too weak. Bottom scatter and bottom refraction of the cape may be significant. The continuous diffusion into the acoustic shadow by internal wave homogenees is a more likely candidate. We favor as an explanation perturbations in lateral refraction associated with the intense mesoscale activity, blah, blah, blah. The conclusion is that the global acoustic transmissions are very sensitive to oceanographic conditions. What the fuck does all that mean? It means originally they wanted to say that the sound diffracted here. And because this is the shadow zone, it created a kink and was diffracted this way to Bermuda. Now, they're saying that this is almost impossible because of the intensity of the wave that came in here. Again, they were not actually talking about this specific, the SOFAR channel and the acoustics on it because they were still being identified. They were identified locally, but no one's really looked at it on a global scale. There's that word again, globe. So diffraction does not account for it. It did not just hit the tip of Africa, diffract, and automatically get received by Bermuda. No. So because they were wrong, someone else did another study. With the other study is this one. Again, if you guys want, here is, take a screenshot. I do have this on the screen, don't I? Yeah, okay, cool. Here's a screenshot. This tells you everything you need to know about what this is. So I'm going to show you just a couple quick things. This right here, this is the Great Circle path, and here's the geodesic path. So the Great Circle and geodesic from the detonation site off Perth, Australia, to the hydrophones in Bermuda. Blah, blah, blah. Okay, so now here's what we're going to come into. These are the actual, hold on, I'm going to get my map over here. Okay. These are the actual signal strengths that were received. So there was basically a 10 dB bump at hydrophone Juliet, which is suspended in the sound channel at 1,300 meters. Then there's hydrophone Gulf, which is bottom mounted. Now they both heard it. However, if you'll notice, there's a second bump right here. And the second bump is the same for all three of them, but they're not here at the bottom. This is caused by, they use another radio term here, multipath from vertical refraction in the sound channel. So as it's refracting everything else, one may become slower than the other. So it shows up like, I believe, 30 seconds behind it. So it was 30 seconds behind it, trailing the principal peak by about 30 seconds and 10 dB lower. So these are the fingerprints of ducting at work as a waveguide. So because they're seeing these, now that creates other questions. What is causing this? How is this going about? Things like this. These are things that we're kind of going into. Now, the SOFAR channel, let me just explain this. SOFAR channel work existed before the 1960 Perth experiment. This started in World War II era. It was a concept exploited by long-range acoustic propagation for rescue locations, primarily. Navy training materials explicitly describes using measured environmental conditions or empirical calibration to determine acoustic velocity and use arrival times to create a fix. A pilot goes down in the Indian Ocean. He drops a depth charge. That depth charge sets off an explosion. That explosion can be heard by hydrophones around the world that are in the same channel. Because they're in the same channel, they can create a bearing. And when you have a bearing, just like that map I showed you with an azimuth and elevation, in this case, you only need an azimuth. Now you get a direction finding and you can triangulate a location to send the rescue. So this wasn't an ad hoc design. This is something that's already been exploited for rescue missions. However, no one went so far as to see how far can a signal go. And that's kind of what this Perth experiment was kind of about. Now, on the wrong page. Let's see. Here you go with the Great Circle routes, like right in the middle, and then you have these geodesics that are on the side. So the arrival delays for a single scatter, refraction, earth flattening is ignored, blah, 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 Great Circle transmission from Perth. Okay, you guys can kind of look up. If you really want to look into this, you can go in this. I'm going to hit the highlights because it is 23 pages, and this is just one of 3 papers we're looking at today. But the key to this, primarily, is that the 2 different hydrophones that heard it, and the fact that the geodesic was the way to look at it. Now, 2008, they decided to have another look. This is by Brian Dunshaw. Dunshaw decided to say, let's have another look at the 1960 Bermuda long-range acoustic propagation experiment. And he goes into a little bit of the history. And he talks about given the nominal estimates for temperature warming. And let me back up one. So no direct path to the hydrophone array is obtained, and the array is found to be in acoustic shadow by 300 to 400 kilometers. The large energy of the 300-pound explosive sound sources required for adequate SNR at the receiver also points at a shadowed reception. So here's the thing. All 3 papers, Shockley, Monk, and Dunshaw, are all saying the same thing. we think it might be this. However, this is very complicated and has a lot of variables, and this was 60 fucking years ago. Yes, this is very close to earthquakes traveling in the world. Very similar. And this is also very similar to tropospheric ducting in the radio world. More my area. However, given nominal estimates for temperature warming on the sound channel axis due to climate change, the experiment repeated today would give signals arrived 12 seconds earlier, but this signal could not be reliably measured because of an inter-annual variability. So they went out and did it again. They didn't stop doing it. They've done this repeatedly times again. In fact, they've done it. The Navy has done it off the Guam and what's the alien chain? Marianas Islands. They've done that multiple times there as well. Because exploiting this channel and understanding how it works and how sonar can penetrate this channel or not is what keeps the Navy alive. Pure and simple. So again, SOFAR is not an ad hoc. It's something that's been exploited since World War II. It was started to be studied in the 1960s and continues to be studied now. Because all these things are, does sonar impact the animal kingdom? Is there tests that impact the animal kingdom? Understanding how this channel works is what happens and understands this. We're talking about coastal defenses. We're talking about sub to sub, surface to sub, airborne to sub detection and things like that. Because you can pump a huge amount of power into something on a sound wave and you're going to kill everything around you. What's the point of that kind of mentality? But what are the advantages of this? Well, here we go. We have the exact same hydrophones again. And here we see that the sound speed gradient that they're accounting for based on latitude, and you see all the lines that go around to this, right? Now, this talks about the acoustic arrivals in the shadow of Africa. I have specific notes on this. Give me a second. I need to find it. Nope. Hold on. Okay, so these aren't parallel lanes following a predetermined freeway. As you can see, they're all different here. And because they're all different, they differ in angles and things like that. So basically, if you change the launch azimuth and the ocean structure, and that path changes, you see these are not all parallel. They don't even have the same spacing, everything else. Each one changes. So just like when you're talking about tropospheric ducting, your angle of incidence, your launch, the distance that it travels, all this adds up. These are all the variables you need to take into. And again, SOFAR is different in tropospheric ducting in that we are trying to actually take control of it and actually understand it so we can manipulate it and so we can take advantage of it, as opposed to tropospheric ducting, which is much more temporary, much more difficult to plan out. So it's more of an anomalous impedance as opposed to something to take advantage of. Also, the very much difference between sound and light, but I digress. $2 from Jim Daniels. Good cover to fish with explosives. Abso-fucking-lutely. So what else do we have on this too? Oh, wait, there's something else I wanted to make a point of. If we go to page 3. Even at the time, okay, so again, this has been done multiple times. The extraordinary thing isn't that sound travels thousands of kilometers. That's kind of like a known thing. We're trying to understand why. But does a 300-pound bomb is the only one that needs to do it? No. Because even at the time, it was known that shots as weak as 4 pounds of TNT could be detected at distances of 10,000 kilometers or more. When we talked about, and he talks about other studies between California and New Zealand and things like this. This is also why pilots had the 4-pound depth charge. Again, come save me takes priority at that time. But there's something else here, and I want to make sure that I talk about it. So, can low frequency ocean acoustics propagate enormous distance? Yes, absolutely. We have multiple studies that show this and everything else. Do we know the exact path taken by every joule of the 1960 Perth signal? The answer is no. We are using computers, we are using models to try to identify it. However, we are trying our best to come up with what is actually doing it. In light of that, we can also do the experiment now under different conditions and see what it is differently. We have more monitoring, we have more buoys, we have more everything, we have more hydrophones. This is why science continues and doesn't stop in the 1800s, the 1940s, the 1960s. Now, there's one more page here I want to talk about. This one only has 5 pages. And I need to find the exact he says Haney. I need to look for Haney here. Control F, Haney. Okay. This discussion here suggests that the Haney et al. Explanation of the arrivals recorded at Bermuda requires topography to influence the acoustic path is plausible, but not definitive. Another possibility is that the horizontal diffusion of the acoustic energy by diffraction or random refractive events, as discussed by Monk, is another possibility. The two arrivals are suggestive of multipaths, but such multipaths appeared to be inherently contradictory to diffusive shadowed arrivals. Evidence supporting interacting multipaths over diffusive multipaths may be found in the results reported by Bryant et al. In 1963. During 1959-1960 experiments, shots deployed in the Indian Ocean were effectively blocked by Africa and not recorded by receivers in the South Atlantic. So, while Monk offered different explanations for the fact of the two arrivals as recorded by Juliet, while only one arrival was recorded on the nearby hydrophone Gulf, which was much lower. It argued that the difference was due to the bottom reflection near the receivers, reflecting off the bottom as opposed to in the channel. Basically, here's what this whole thing says. Okay, this whole last page. And again, I'm going to do something that conspiracy channels don't do. It's going to be very simple. The later literature does not say, case closed, we know the exact mechanism of why this happened. It says long-range propagation is real, but restructuring exactly how the 1960 energy-penetrated Bermuda's acoustic shadow remains complicated. That's what it says. Because you would need ocean measurements from the entire path. You would need to know the conditions, the time, everything. And these change moment by moment. Trying to reconstruct something 60 years previously or 40 years in the previously is difficult. There's no denying that. But here's my question. My question is this. We have the SOFAR channel, which allows it to bend and refract and go around different locations based on a vertical profile. We have various tests that show this that are all dependent on a geodesic path. What does flat Earth have to sit there and say that this proves a flat Earth? Because this is Perth here. This is Bermuda here. So I'd like to know how this proves a flat Earth, or is this just one of those cop-outs of, well, falsification is independent of replacement. Here's the thing. We have studies. We have the Navy, multiple navies who utilize this channel, know its properties, and use it as much as possible to gain advantage over other navies. It's taught in schools by the Navy. It's taught in schools for science about sound propagation. Show us where there's any studies that shows that could be possible on a flat Earth. Because I'd like to know if your study shows that it could bounce off the ice wall, which coincidentally, like my drink, ice floats. Or does it refract off all these? Does it diffract off all these? Does it bounce periodically? Does it get trapped in the ice wall? Does it go out of the water through the air and drop into Bermuda that way? I'd like to know. Because anybody who uses this, and coincidentally the Perth-to-Bermuda, as proof of a flat Earth doesn't know shit. Because as much as we know that a waveguide can actually change the vertical spread of sound and light, that's how it stays. We don't have to worry about curvature. You have to explain why you have all these round circles that it goes around and everything else. I only have to account for one. So, nuh-uh is about all we're going to have. And that, my friends, is this. But what does this actually mean for other things, right? Because, I mean, this is all cool and all, but, like, who cares, right? Well, no, everyone cares, because here's the funny thing. So there was some observation validation. So axial seamount source transmitted twice daily and was used for calibration and model validation over long paths. This includes Heard Island, which is known for low frequency coded transmissions from the southern Indian Ocean, were detected at ranges up to 18,000. Acoustic thermometry, which is repeated long range acoustic travel times. Basically, at some point, unrepeatable phenomenon becomes we put it on a fucking schedule. That's my point here. Now, here's the other part I want to bring up too, is the Navy continues to use this because of SOSUS. So up until recently, SOSUS is a surveillance infrastructure exploiting long-range underwater acoustics. It fixed hydrophone arrays, undersea cables, shore processing, beam forming, bearing estimation, submarine detection and cueing. Basically, what this does is this allows us to protect the United States and track Russian submarines throughout the Cold War. By utilizing this channel, we have an absolute application that lasted decades that provided us insight. And let me go to the other map, to where between Norway and Iceland and Greenland, we had networks that would allow, and we also had southern networks that would allow people, or that would allow us to track actual sonar through sonar. We through hydrophones, we could track the acoustic signature of submarines long distances, so we know when they're coming. Side note, during the Cold War, there was a certain rating or job in the Navy called an OT, which was fuck, I forgot what it was. Hold on, it's oceanographic technology. No, hold on. I think it was an OT. Ocean Systems Technician. Okay. So the Ocean Systems Technician was established in 1969. It was classified. You could not you could not actually wear a rating badge that had your job on it, and it was not a job you could actually talk about. In 1982, they actually took two different ratings and combined them. In 1998, OTs became declassified and were merged with sonar technicians because they were differing. And they were differing because of how they were actually doing. So if you had a sonar man harbor defense, or sonar man that was on the water on ships and submarines, each one had a specialty rating. But when you were shipboard and you're an OT, you manage the SOSUS, which was the sound surveillance system, the AIS, which was integrated undersea surveillance system, and things like CERTAS, which is the surveillance towed array system, and the RDSS, which is Rapid Deployable Surveillance System. All of those systems were run by OT ratings, and those OT ratings were classified all the way up until 1998. Their whole job was to manipulate this channel and to use it. And that, my friends, is why we have the SOFAR channel and how the Navy uses it. So, I had a question yesterday from Nick. I don't know if he's here or not, so hopefully he watches this. I have to find it. Give me 1 minute here to find it. Let's transition a little bit here. Where did I put that? Let me do a search. Is that what I think that's what it was. Where was it? Well, it's searching my hard drive because I saved it in Notepad and I can't find where I put it. Oh, here it was. Does water turbidity affect the range effectiveness of passive sonar? And how about biological materials, things like kelp and plankton? And so basically the answer is, or the question is, when you have active sonar and passive sonar, does passive sonar get affected by various things outside the layer? So organics, things like kelp, plankton, things like that. So, and even the turbulence in the water. So yes, the turbulence affects the passive sonar, but it differs how it would for vision. So sound and light, right? So differences. So for passive sonar, the main questions are whatever's in the water, is it going to scatter the sound, absorb it or attenuate it, or does it raise the background noise floor enough so it can't be detectable? So things like murky water, suspended sediment, and things like that can scatter and attenuate sound, but the effect is it's dependent on particle size. I mean, that kind of makes sense, right? Plankton can create acoustic layers, scattering layers at higher sonar frequencies, but again, the lower ones aren't affected as much. And again, so the particle size is also frequency dependent, things like that. Kelp can matter, especially species that have those gas-filled pneumatocysts. Fuck. I haven't taken marine biology in forever. The little bubbles on the kelp. Okay, depending on the size of those, they can alter scattering, attenuation, everything else because it's an air pocket, right? And then biological noise itself, things like echolocation, things like that can also affect sonar. So it can. There's different things that can affect sonar, but it's going to be largely dependent on things like particle size, frequencies, and things like that. So murky water itself doesn't block sonar. Passive sonar can see through it. But what does matter is scattering, absorption, noise, and those are highly dependent on frequency and things like particle size and things like that. So, Nick, there's your answer. I hope it was enough. There it is. Thank you, Nick. I just had to go look for it. I had it labeled and I couldn't remember what I used because I took your wording and then I saved it as something else and I couldn't find where it was. So Jim Daniel says, I like the thorough explanation of the testing and the results. Very understandable. Then the segue to the FE map and how does this work was the chef's kiss. Thank you, Jim. I appreciate that. Dougal, just to clarify, was the earlier diffraction around the Cape theory overridden by this SOFAR channeling? Or was it a combo of the two? It's sort of the combo of the two. So so it was, no, let me rephrase that. It was kind of overridden. So it wasn't overridden The first one was wrong about diffraction. The reason why it was wrong is because it didn't explain the level, the level that the sound was receiving the hydrophones. It was too powerful to just be diffraction. And there was a couple other things that were thrown in there, like, bottom reflection and things like that, that were also included in that, but it doesn't account for the multipath that showed up. So it's not so much that the diffraction was wrong, it's that it could be part of it, but there's other things that were missed that weren't actually discussed. And then later when they looked at it and they said, hold on, diffraction doesn't account for how we should have received the signal much lower than what we did because it was in the diffraction's shadow zone. I forgot what the math equation is for that, but it's very similar to radio when you have diffraction over the Earth. When you get in that shadow zone, the power level or the sound level or thing that starts dropping very, very quickly, like almost off a cliff. Within the first 100 kilometers, you've gone from a signal noise ratio of, hey, I can hear everything to I'm deaf. So it doesn't account for it. The additional studies went to say, well, look, your thing only works on some sort of, great circle thing, like, using that as your premise. If you use a geodesic one, you get away from the great circle, or you expand the great circle in both directions, and you find out that diffraction is less involved, and would also explain why the receive levels were the way they were. So hopefully that answers your question. What does Bruce have for me? Let me find out. Not that I don't trust Bruce. I'm just trying to figure out what it is. Oh, wow. That's actually a really cool idea. Hold on a second. Let's do. Bruce, that is a great article. I'm going to have to read that. Yeah, go to site, dude. Thank you. Okay. Need to track a submarine? A harbor seal can show you how. Using lessons learned from harbor seals and artificial intelligence, engineers in California may be able to find a new way to track enemy submarines. See, here we go. Now I got something else to read. Hold on a second. Let me transition this over so you guys can see this. And here's this article. So click that link if you want to read something interesting. I'm going to read it later. I think it'll be interesting for sure. So let's see. We totally destroyed flat Earth and cooked a bunch of morons on TikTok talking about the GEO's or GOES 19 satellite and different azimuths and elevations. Doesn't matter if you take them from a flat plane, like Roger says. Doesn't matter. We talked about Sonar, cleared those up. But since we're talking about Roger, let's hear what Roger has to say. Because Roger, well, he's Roger. Shit, where'd I put it? Downloads? Yeah, here we go. Oh, okay. So let's bring this over. Let me pull up. Okay. Volume all the way. All right, let's see what they have to say.
That wasn't really a debate, but I mean, the thing that radar proof that Craig brought over, we debunked it like the next day on 2 different streams, and even people on his own side said that's not why you have a radar horizon. It's not Earth curve. Like they all like, shut up, Craig.
I'll take things that didn't happen for 400, Alex. So this is back to Roger's coattails final debate, where he was going to donate $20, which we still don't know what he was going to do, per flat earther or per globe earther who brought up proof. FTFE brought up radio horizons, and Roger Ledwell, in his vast knowledge of radar, didn't know what it was. Apparently he had to go ask Dad. He did not get it in his osmosis learning from his dad, who was, in the Navy as a radar tech. So, and supposedly he went on stream on Flatzoid's channel to do this. But let me finish. Let me let him say what he's saying, and we'll tie this with a nice bow.
But I mean, when you get that kind of proof from those idiots, it makes them look stupid. It just does. That's the proof of Earth curve radar. The SAMPSON radar, it goes over 450 miles in a straight line sight, and you can pick up any image. So where's the Earth curve in that one? There's 450 miles of non-Earth curve. Let's go with that.
What
Yep.
curvature, man? Come on. I was in the middle of the sea, in the middle of the Mediterranean. I took my phone out. I was trying to
Yeah.
reach the curve, I was trying to film it, but I couldn't. All I saw was flatness. You could lay a fucking house on top of the sea, flat.
Thank you, Santero. I appreciate the.
That wasn't really a debate, but I mean,
the
the
fuck
thing
up,
that
Roger. Thank you, Santero, for that idea that you do not understand scale, and that you're talking about something visual while Roger was talking about something in the EM spectrum. But hey, let's talk about SAMPSON, shall we? This is the SAMPSON radar. The SAMPSON radar is kind of like the newest one for the UK. It's built by BAE Systems Maritime. It has a 400 kilometer range. Its power is 25 kilowatts. And it's not your typical radar of, if you're thinking like a dish that spins around at the top. No, this is what we call an AESA. Now, AESA is basically a steerable radar. It actually stands for active electronically scanned radar. So basically, there's another radar that works in the background, and it's more passive. It doesn't have as much strong power, but as it receives a signal, now it sends that to SAMPSON. When it gets to SAMPSON, SAMPSON can direct all its power to that beam. It can direct its beam where it needs to go. Very simple to put. Everything else. There was a quote here. I'm sorry. Yeah. So it's being used for the Type 45 destroyer. It's the Daring class. We'll come back to that in a minute. So its operation is it's a conventional radar consisting of a rotating transmitter and sensor, like I talked about, have limited power and are vulnerable to enemy jamming. And they perform only one function with separate units required for surveillance, tracking, and targeting. So you need 3 different systems. This one does all of it. SAMPSON is very comparable to Aegis in the U.S. Navy. But instead of a dome on the top, they have those little panels on the side, everything else. So for those who don't know, let's just do, let me show you what an Aegis destroyer looks like. These panels that you see right here, these panels you see right here and back here, those are the Aegis panels that are the array. Those panels are all hooked together, and you can direct your array to whatever panel you need to whatever azimuth you need to take a look at things. SAMPSON does this in a dome. Big deal. So, but there are differences. SAMPSON uses 2 planar arrays to provide coverage over only one part of the sky, because it uses another radar in the background to give an idea where to look. Complete coverage is provided by rotating arrays, similar to the way conventional radar systems operate. This is contrast to the SPY-1, which is part of the Aegis combat system, and the SPY-6, which is the most recent one, and the Dutch APAR system, which is theirs. But here's something interesting about the SAMPSON. Says, although SAMPSON radar does not provide continuous 360-degree covers, it rotates at 30 revolutions per minute, and with 2 back-to-back arrays, no part of the sky lacks coverage for more than half a second on average. Placing any radar emitter at a higher altitude extends the horizon distance, improving performance against low-level or sea-skimming targets. Why would that be? Because you can't say angular resolution, it's not an eye. You could say angular resolution in the sense that the 400 kilometers is a hardware or an instrumentation maximum number. Does not mean everything is 400 kilometers away. What it means is that it can detect things up to 400 kilometers away. But we're going to come back to that in a minute. But why does raising the emitter at a higher altitude extend the horizon distance? Because it's fucking curvature. That's why. because your radar horizon is dependent entirely on the height of your transmitter and the height of your target. Case closed. Curvature. That's what FTFE meant when he brought it up to you, and this is what you don't understand. Because if you don't recall, we had a couple geniuses tell us how this works. Do you remember this, geniuses? Where you said one radar points up, one radar points down, and this middle area right here, this is your radar horizon. Yeah, because you guys are dumb as fuck. That's why. So what is the daring class? What is this nice little destroyer? Oh, look, here we go. The daring class consists of 6 Type 45 destroyers with all the names that all start with D. You guys, hey, in the UK, you guys do realize that there's more than one letter in the alphabet, right? Okay. That were purpose-built for anti-aircraft and anti-missile warfare. So what is their primary method of, well, what is their primary mission? Anti-aircraft. So why would you have a 400-kilometer radar? Because your targets are higher, you can see them further. Yes, yes, that stupid MS Paint drawing absolutely would make a blind spot in Seaborn. And here's the thing. Hold on. Where did it go? No, I need this. Here we go. Nope, not that one. Not that one. Fuck, where did I put it? Oh, this one. Oh, I'm sorry. Let me rephrase this. So this is radar principles, NEATS module 18, NavEd tray 14190. All unclassified. But it tells you the principles of radar and how it all works. But here's the fun thing. The part that works the most. The part worth expanding upon because it's fun. Where we talk about antenna height and why it matters. Because this is why something's below the horizon, but something is up high. Why the fuck does it matter what the actual the target elevation is if there's a convergent zone? Because it should, their excuse does not fucking work. Pure and simple. But look, you know what? Hold on. I'm going to put on my Flurf hat. Shit, I should have made one out of tinfoil. I don't have one. I'm going to put on my Flurf hat and I'm going to do a little COPE forecast. Well, that's the U.S. Navy. What about the British? Oh, funny you should ask. Funny you should ask. Funny you should ask. Oh, look, chapter 15. Radar theory and application. This is in BR 4451, which is the Admiralty Manual of Navigation, Volume 1, Part 2, the Principles of Navigation. So again, you can go look this up yourself. Radar theory. Let's go through this. Let's see what they have. Let's see, wave theory. Okay, that's fun. Radar detection, factors affecting radar detection. Digital radar. Computerized tracking, range discrimination and minimum range. Okay, that's all fun. Radar beams. Let's see, bearing. Yeah, that's all fun. Okay, great. Where am I going here? Oh, fuck, what's this? Atmospheric refraction, distances at the distances of the sea horizon standard atmospheric formula. Look, You see this 2.23 in the square root of height in meters? It was very different than the other one we had up, which has 1.25, the square root of the antenna height in feet. There's a metric conversion there. Metric conversions are fun. Holy fuck, what is this? This shows you why it matters. Talks about different types of refraction, which they don't understand. Talks about super refraction. Oh shit, look at this. Oh my God. Likely super refraction areas. It's almost like somebody went out of their way to do some fucking testing around the Azores, around the Canary Islands, around the Persian Gulf, between Hawaii and California because of trade wind inversions. Holy shit. It's almost like the UK knows the Navy knows what they're talking about. And all the shades of gray where meteorological conditions causing super refraction are likely to occur on 1 day in 5, i.e. a 20% chance of it occurring. This is almost like the EREPS document from LoRaWAN. Oh, wait, January and July. Why is it different? Huh, I wonder why. Oh, here's how weather impacts radar. Okay, what else do we have? Oh, let's see. Oh, look, rain. Okay, that's always fun. Cold fronts. Oh, let's see. Warm fronts, San Andreas storms. Do. Interesting. This is a little more in depth than what the U.S. Navy has. Goes into index errors. That's part of what the computer does, so we don't have to do it anymore. Let's see. Pulse length and width, sea clutter, aerial heights. Sea clutter. Holy shit. This looks a lot like hold on. That can't be right. That looks like that, but different. Why is it different? Oh, because it's very similar. Oh shit, look. So you can use a document like NEATS Module 18, or you can use the UK version of, which is what I have now, which is BR 45, which is based on applicable engineering, decades of use, or you can trust the guys who have never sat in front of a console, never even knew what a radar was, and, they draw stupid shit like this. So, yeah. I'm not sure where you think you debunk shit, Roger. If anything, you just showed your ignorance. So, let me go back to one more thing here. I gotta go back to my notes. Hold on. I want to make sure I touched everything because. Oh no! Wait, we had other things to talk about. Hold on. Wait. Here's something about the SAMPSON radar itself and how it's used for. What's the word I'm looking for? Oh yeah, anti-aircraft. So this is an in focus article, technical briefing on the SAMPSON radar itself. Basically goes into its use, how it was developed, how it kind of works in a general sense, and everything else. But it doesn't change the fact that it is purpose-built for anti-aircraft, anti-missile warfare. And why is it purpose-built for that? Because it has a 400-kilometer range, and because it has a 400-kilometer and not 400-mile, Roger, but I forgive the conversion problem. Because it's 400 kilometers, height matters. So a sea-skimming missile is going to have a range of 40 kilometers. A plane of, I don't know, I did some quick math. What was it? Okay, so the radar height's roughly 40 meters high here at the waterline. So its distance to the horizon is roughly 40 kilometers. So if you have a high air target, it obviously extends it because you can see it further. Because we can go back to this and say you raise this up, you can see further over the horizon. Not difficult, real easy to understand, unless you're Roger. So, yeah, so the 2018 BRD 45, that was actually that's actually a really cool document. I'm glad I found that. That was pretty cool. It's nice to know what the UK people are talking about. There's actually a little more in depth than the Navy ones. So highly expanded. Roger opening his mouth will usually show his ignorance. Yeah, that kind of goes without saying, I think. Not surprising. But here's what I've said this before and I'll say it again. I have an open channel. I have an open challenge. If you want to discuss how telecommunications or the EM spectrum proves the earth is flat, I'm not hard to find. Send me an email, unfornicated@gmail.com. You can find me on Discord. You can send me smoke signals. I don't give a shit. Come on up. We'll put up a Zoom link. I'll let you talk. I've proven I'll let people talk. I let Dave talk for over a fucking hour without debunking him right on the spot. You can have your say, and I'll show you where you're wrong. Not hard. Because radar, radio, undersea cables, and satellites all prove we live on a globe. And I actually have experience in all three of those. So I'm not saying you need experience, but it helps. All right. I think I covered most of what I wanted to cover. The sheer stupidity was enough. I'm just trying to think, what else? So yeah, 400K statement for SAMPSON. That's strictly for, that's the instrumentation limitation. That's based directly on hardware, frequency, things like that. How big and whether or not you actually, if you have a stealth plane that has a smaller radar cross section, you're not going to see it at 400 kilometers. It's going to see it a lot closer, if at all. There's a bunch of things that you have to take consideration that they don't. They go out and they draw this and think it explains everything. I don't know what to say to that, except this has got to be the absolute fucking dumbest picture I've ever seen in my life. That plane be nose down. Probing. Thank you. Yes, the Tomahawk has a range of 1,600 kilometers. That also has active guidance from GPS and terrain avoidance and things like that. So Earth's still not flat. What meds am I on? It's called Bumbu Rum. That's what I'm on. Yeah. Like at 40 kilometers, hold on, let me see something. I've been meaning to do I wanted to do like a declassified files on anti-ship missiles, and I haven't yet. So I got to ask, I'm going to have to ask my search engine here to give me something real quick. So while it's thinking about that, so at 40 kilometers, let's say its radar horizon is 40 kilometers where it sits. Let's say it's in the Persian Gulf where they have exocet anti-ship missiles. Now, an exocet, fuck me. An Exocet missile flies at Mach 9 to 9.3. So let's call, I don't know, it's about 300 meters per second, roughly. My math is going to be a little off, but let's say that. So at 40 kilometers, flying at at 300 meters per second, and it's going to be within the first, say, 100 feet. But let's say it's surfing the waves, okay? You'd get roughly 2 minutes from first detection until impact, assuming, straight radio closure, and it doesn't do any evasive maneuvers. 2 minutes is a lifetime when you have a system like SAMPSON or AIS set to active, because there's settings you put into it where it does not need human intervention. But even if you had 2 minutes and 11 seconds, if you have a sea whiz, remember that's the phalanx with the erection, or you have anti-missile missiles or other devices like chaff and flares, 2 minutes is a lifetime to make your reactions to save yourself. That's why, like a crow's nest on sailing ships, it's put at the top of the mast. If it was flat, it wouldn't fucking matter where it was at. Yeah, it's a little bit faster and you can run copium. Whale panties coming out. The shark fact of the day. White clasper cat sharks, again with the cat sharks, dude, are named for their stark white claspers that sharply contrast with their dark brown bodies. Thank you, whale panties. All right. We're done with the debunking idea of this, I think. Let's see. I think everything else I have here is going to be for kind of like a next topic. So let's talk about some stupid shit. Because, well, actually, here's what I do want to add. I do want to do something here. Hold on a second. Where did I put it? I didn't put it there. Where did I put it? I don't know where the hell I put it. Oh, fuck me. All right. I may have closed it. Hold on. Let me open things. Because I want to make sure that I'm not making a straw man, that people actually say stupid shit, right? Because that's what we're here for. So if I go to this, oh, I had it open. Fuck. Okay. Transcript. Okay. Let's see. I need to look at my phone. Let's see. Where is Sonar? Where did we talk about Sonar? We talk about Sonar at 740. 740. LoRaWAN. Yeah, we don't have to hear about that. Okay. Hopefully this comes through. Here's Dave himself talking about Sonar.
The ocean, half of the ocean is the abyssal plain, where they say it's flat, and submarines sitting on the bottom of the ocean can send sonar out and see other submarines over 100 miles away. There should be over 6,000 feet of curvature hiding those other submarines. So that means that the sonar would have to go over, hit the submarine, and then bounce back like that, which is impossible. The ocean,
which is impossible. Right. Oh, here we go.
From sound. I'm with you. and the other thing is, you'll notice that all of the globe excuses are complicated. Right. Flat Earth is no, it's because it's right there. It's just like
no. All the globe excuses are complicated, but Flat Earth is no, it's right there. Here's the problem. Why don't you see another boat more than 40 kilometers away and that you can detect it strictly on a model that includes a globe, that shows a shadow, that shows that you're flying under the radar? Why even have sea skimming missiles for detection problems when you could shoot them way up high as an ICBM and come back down through the atmosphere. Because that's a lot harder to hit. No, it was just audio. There's no video, Jim. I did not record video. I only recorded the audio. Hopefully that came through. Let's see. Let's see. Talks about flatten the curve. Oh, here we go.
So, dumb question.
No dumb question. Actually, they're all dumb. Go ahead.
Yeah, I agree. I agree there. So the way I look at it is like, obviously, some people don't want to be tied to something that's open to ridicule and stuff like that, right? Because
we're all taught we want to belong to the tribe.
Right.
Right.
So, out of curiosity, did you vet these, or did Mark vet these veterans? Like, did they ask for like a DD-214? Same with their job.
Yeah, no, watch flatten the curve. It's all, these guys are all vetted. They give all of their information. Okay. You can verify it all. So again,
again, I would love to as a veteran.
In today's world, bakery, you have to verify everything, and it's really hard.
Right.
It's super hard.
Well, I mean, if you have the person's name, you can file a FOIA request and get the record.
It's all there.
Okay.
It's all there in that video. The problem is Google will never give you that video. You have to know how to get to it.
File a FOIA request.
No. You can find that video pretty fucking easily. How do we find that video, I wonder? Haven't we covered this on this channel multiple times already? I believe we have. And my typing today is getting worse. Drop a dirt charge on Dave. Copium, I like that. You know what? I'm not going to fucking do that. Let's just do this. Whoops. My typing today is off. Maybe he has a point here. Oh, look, I found it. And if I seem to remember what these guys are talking about was... Hold on, let me find them. Oh, yeah. So these guys are all vetted, remember? All vetted. Let's see, Merchant Marine. Yeah, I'm not really... Okay, his name is there. I'm not looking at him. I don't know if he's a veteran or not. Doesn't matter. Yeah, okay, yeah. The fuck, dude? Yeah, we already looked at you. Oh, here we go. Here we go. Remember, these guys are all vetted, okay?
You can just call me Jay. That's what my friends call me. That's what I go by. I just go by Jay.
Okay, so his name is Jay. And he's in operational intelligence radar navigation. No such rating. Are you a navigator or are you a radar operator? There is no operational intelligence. There's an operations specialist, or what we call an OS, who operates radar. But you know what a radar horizon is if you were that, and you wouldn't be so fucking dumb. We've covered this guy before. So in other words, no, they weren't vetted. $20 from Stop This Stupidity for having to put up with Dave for so long. Thanks, bud. I appreciate that. It was actually kind of fun. I wanted to bite my lip. I had to bite my lip, bite my tongue, bite the inside of my cheek. When you brought up LoRaWAN, microwaves, sonar, and he brought up some of these other things that are obviously, and like I even baited him in undersea cables into saying that, oh wait, where's that one? Hold on, I want to find No,
Hey,
stop.
Brad.
Control F. Um, we talked about a break in a terrestrial fiber optic cable. He says this.
The distance.
Very, very few people will be involved with a break in the middle of the ocean, and you're not going to know how far you are. You're not going to know anything. And
No, I tell them how far
if
they
you
are.
actually look at the fiber optic, the layout of the undersea cables, they prove flat Earth because there's none in the south. They all go up to the north and back
There's
down.
none in the south, and I'm sorry for the audio quality. The wind was picking up, and there was a lot of people talking around us. I bring up the fact that there's Southern Cross cables that go between New Zealand and Australia. I brought up the fact that Google was laying one between South Africa and Perth, and that there was another cable going in between Santiago and I think it's going to be part of Southern Cross, so it goes to French Polynesia, I think. But he says no one will ever be involved, and no one will know what the length of the cable is. No one will be involved in the plotting or everything else like that when we have to know when there's breaks. How else do you fix it? Drunk Debunk Show, because Dan is awesome to chill with and do stupid stuff together. Hey, Mike. Yeah, we did a lot of fucking stupid stuff together. I want to get to the point. Here.
In the south.
So we know distances. Like I'm almost positive there's got to be a cable between New Zealand and Australia.
Probably is.
Okay, so
Probably is.
So we would know that distance, right? How would I want to follow your your thing? How would I be able to use? What is this, by the way?
This is the AE map.
Oh, AE map. Okay. So how would I confirm distance between point A to point B?
You wouldn't be able to. You can't confirm distances over water. Now, if you were the cable guy and you knew exactly how much cable, you can confirm it. But who is that person? Who has that information? The CEO.
The CEO has that information. That's who has that information. $20 from Gravity Pen. Satellite transponder spot beams deform across the surface of the planet and match the globe. Funny that. The deformations appear quite wild when projected onto a flat Earth. The edges can be traced by anyone with inexpensive equipment. Yeah. I mean, I was showing something similar to that. I don't know if you were here, Gravity Pen, but I made this. This is for GOES 19 and 4 stations: Bermuda, New York, Chicago, and San Jose. And on a flat Earth, they do weird shit. But on a globe, they all do that. Huh. Why is that? So I can't wait to put this in a video. So, all right. You guys have any questions about sonar, radar, radio, things like that? Otherwise, we'll go on to my next topic I would love to talk about. It's going to be fun. Yeah, who's the CEO of the internet? Nick, that's a really good fucking question. Because here's the funny thing. I'm not the CEO. I was a field tech. I had an OTDR. I knew where every break was because I sent signals, namely light, in pulses down the fiber. And when they created so much scatter, it would bounce back. And it would tell me, hey, that's where the break is. And it figured out the distance because we know the speed of light through fiber optics. Fucking amazing. Now, that's one way to test fiber. I've already shown a second way to test fiber that apparently Dave doesn't know about and should be part of, oh wait, it will be part of a video, where I can use pop-to-pop measurements and latency measurements of certain cables to prove that separation of longitude converge at the exact same latitudes, and it doesn't work on a flat Earth. Amazing how that gets there. I was in stealth mode. Was Mike hidden under his shirt? No, that was Mike. My mic was actually on the back of my phone. And the problem was if I held it like this, it was open to the air. If I held it like this, I was blocking the air. I had moved the phone from one hand to another, and that's what caused the problem. Hopefully you guys can still hear it. Dougal wanted to ask, would SAMPSON be better at detecting sea skimming missiles than previous versions? Absolutely. Absolutely, it would be. Good night, Curious. Thanks for stopping by. 5 minutes till tune. Is tune really going on later? Oh, well, fuck. I guess I better hurry up, and then I'll send you guys all over to tune. So what are we going to talk about then? We have one last thing to talk about. I'm going on vacation. I'm going to go spend a week. I'm spending a week in a location called Cape May. It is down here at the ass end of New Jersey, which coincidentally is right here by this bay, which is right here on this waterway that goes all the way up to Philadelphia. There are lots of traffic that goes through here. I'm going to be here for a week. I have nothing but time. One of the things I'm going to do is I'm going to set my happy ass. I'm going to rent a P1000 for $100 because I won't fucking buy the goddamn thing. It's a piece of shit. I bought a really big tripod to put it on so it's nice and sturdy and level. And I'm going to park my happy ass on Sunset Beach, sitting right about here, right near the point. And I'm going to take a picture of these 3 lighthouses. There's going to be a little bit of obstruction on this one. They'll be mostly obstructed on this one, and you won't be able to see this one at all. However, directly behind this beach is a World War II watchtower. I got to find it. So this watchtower that we see here is 70 feet high. From 70 feet high, I will be able to see this third one that I cannot see from the beach. And I will zoom in and we'll do measurements because I'll know the GPS location of all 3 of these. And if you notice, all 3 of these look very similar in pictures. Hold on. Fuck. All right, we'll do this. They all look like this. So when you look like this, there's very much easy measurements to make and know how everything is. So when we have these, I'll be able to measure out all of the stupid obstruction. And all 3 of them are looking similar and they're all different colors. So that's the first thing we're going to do. Now, again, I need your guys' input on this. I need to know if I'm doing it right. So that's the first thing. We are going to shoot a picture from the beach and then from the tower to see these 3 lighthouses. 1, 2, 3. The third one is too far away. You will not be able to see it from the beach, but you will be able to see half of it from the watchtower. Number 2. Oh, actually, that's 1. 1A is going to be turning around because there's another watchtower here, and we have Harbor of Refuge Lighthouse here, which looks exactly the same that way. We're going to look now south, and we're going to size up both of these, all with a P1 million. So that's number 1. Whoa. What happened? Hold on. I just lost something. I didn't lose frames. Why'd I lose? Oh, fuck. YouTube decided to shit on me. I'm sorry. Am I still live? I think I'm still live. Yes, I'm still live. Okay, cool. That was weird. All right, let me move this back around so I can see chat. All right. So yeah, so 80-foot waves would have to explain why I can't see things because Dave says that also, by the way. Boston Concerts. I might reach out to Cape May Astro. The problem is I'm already taking family time away to do this stupid shit. I don't want to take all the nighttime away too. So we're going to shoot this way from the P1000. or P1 million from the points at these two lighthouses. Then we're going to do something else. So that's 1A, 1B. Number 2, there's a ferry that goes between these two lighthouses. In fact, that ferry looks a lot like this. It's fucking huge. It carries cars. It carries people. It's over 300 feet long. It has a very distinct paint job. In fact, it goes black, white, blue, white with windows, and even some weird shaped stacks in the back. Now, here's the fun thing. They go every 90 minutes. It's 90 minutes across, 90 minutes back. I will sit my happy ass down in a chair with a P1 million, looking at this as it goes away from Cape May towards Delaware. But no, that won't be enough. I'll have my drone with me. I will sit there and be able to calculate how much is actually missing. There's buoys in here that are going to tell us what the sea state is and how high the waves are. But I'm going to watch it not just go to the horizon and stop. No, it's going to be recording all the way till it's all the way over the horizon and there's nothing there but sky. Because then I'm going to get that same fucking boat coming back. And it's going to match the same way going out. And it's not going to be angular size. That's number 2. Number 3. Well, like I said, this is a pretty large area with a deep water channel. And the great thing about deep water channels are that they allow a lot of big boats through. Big boats like this big boat. Like this big boat. Now, why does that matter? Well, because it's not a little boat, it's a big boat. So while I'm sitting here in Cape May with a P1 million tied to this boat, watching it go out or coming in, depending on what I'm doing with, I'm going to have a radar. I'm going to have a radio antenna next to me. That radio antenna is going to be on a 20-foot painter's pole into a beach screw into the sand with my laptop on my lap with my SDR, and I'm going to be receiving the AIS signal from this ship. I'll be able to see the ship as it leaves. I'll be able to take the name from it, focus in on it, focus into a paint chip as it goes out. And I'll keep watching it as it goes out. And I'll keep receiving its AIS signals that tells me its GPS coordinates and its range from me. And even then, when it goes over the horizon, we can no longer see it. Because my antenna is 20 feet in the air, I'll be able to still receive it and find out what the distance is. And guess what? It's going to match whatever the refraction is for the day within an error margin, and it won't be angular size. That's number 3. Number 4. I don't remember what I have for number 4. Hold on. Give me 1 second. Let me look at my notes. Number 4. Nope. I'm also going to be getting a solar filter and a near IR filter. So just in case it's a little foggy, I'll be able to put on a filter and voila, cut through the haze and we're golden and we'll be golden. Let's see. Commercial ships, AIS, the ferry, Delaware side experiments, Delaware Bay lighthouse experiments. Yeah, that's everything. So good news is, as of right now, it looks like when I'll be down there, the temperature of the air and the temperature of the water will be within 10 degrees of each other. Excuse me. So should have any crazy refraction going on. We'll wait and see. I'll have access to all the sonar or all the buoys to provide us with the sea states and how big the water is around there. We'll have weather balloons because there's one launched south of here, data that I might try to track. If I don't, who cares? But at least I'll be able to download the data that'll tell me everything we need to know about the atmosphere in the area. Because the cool thing is that Cape May is a Coast Guard site, and I can get all the information I need from the Coast Guard. So, when I do the ferry, I might be down here on the point. Because since the ferry comes out of the terminal right here, There's this nice little breakwater right here. It's a fishing. Look, it's a bunch of rocks with, you know, usually fishermen on there. I'll park my happy ass right here or right here, and I will just sit there and in a seat for 3 hours and just watch the ferry go away, watch it come back, drown myself in flurf tears and rum, and call it a day. Yeah, I was going to pick up, I have a circular polarizer too. So I'm going to pick up a near IR. Yes, I'm going to go ahead and spend money on these filters for a camera I don't have, but hear me out. I will sell them as used on eBay right afterwards. I don't care. I'm going to get a circular polarizer, near IR, and a solar filter. Because that's the other thing. Oh, that's the other thing. I'm going to take pictures of the sun as it rises in near IR. Or with a solar filter. So we can ask the bottom, hashtag where bottom sun. Just like we'll be asking where bottom boat. And the problem is I have a large enough drone, but I don't have one that has like a P1000 lens on it. The most I can zoom in is 3x. But if I can get to the point where a ship is just starting to go bottom up horizon, and I can send the drone up and capture the video and see that the bottom up now has gone away because the ship is black on the bottom. Can't really say it's angular size because as we go up, the distance between the ship and the camera is going to increase because the hypotenuse in the triangle is longer than the adjacent side. So that's what I have planned. I'm doing this because people are dumb and wrong on the internet. So if you think of a better experiment, if you think there's something else I could be doing better or different, you all know how to reach me. You can reach me on Discord. You can reach me on emails. You can reach me on smoke signals. You got to let me know which way to look, though, because, you know, directions. You can reach me. I mean, everyone knows how to reach me. You can reach me in the comments section. And actually, if you're here, go ahead and like the stream if you enjoyed it today, so we can get those likes up. And if you didn't like it, well, hit the down button. I don't give a shit. Leave a comment. If you're new here and liked what you saw, hit the subscribe button. If you haven't subscribed and you've been here multiple times and you find yourself coming back on the regular, hit the subscribe button. You're helping me out. Doesn't cost you anything. But that's what we have planned. You have an unfiltered sunrise video. Okay, cool. I want to get a filtered one. I want to cut the glare. I want to cut the bullshit. I want to just Occam's razor the fuck out of everything to be, where's your excuse? You can't tell me the ship vanished and sank because I see the AIS from it. And I'm not using marine tracker. I'm getting it straight from the boat, straight to my antenna. To me, that's kind of like that's a chef's kiss, like little go fuck yourself that I like to have on there. Because here's the other part. When I lose that ship, I'll know what its last position was. And from its last position, counting my antenna height, I should be able to be within an error margin of how far it was based on that refractive index for that day. Because science and math. Why not just rent a plane and do multiple AIS approaches? Nick, get out. You bastard. Yes, they'll still be dumb on the internet afterwards, but you know what? I'm doing look, people can come to me and say, you haven't tested anything. Wrong. Here's my P1 million shots. No one else's. They're mine. I did them. I can provide you all the information. I'll take pictures of everywhere I'm around. I'll show you exactly where I'm at. I'll take out my phone and say, here's my GPS coordinates. I will do everything possible to make it as robust so you know exactly where the fuck I am. Actually, the interesting thing is there is a wreck. There is a wreck right here. So here's the watchtower. I think I'm still sharing. Am I still sharing? Hold on. I'm going to make sure my OBS is up. Okay, so here's the watchtower right here. And if you want to know what it looks like this. It's 70 feet up. Okay. Here is a well-known wreck. This well-known wreck is the SS Atlantis. So I will have this in the video so you know exactly where the fuck I am. And look at all those container ships out there in the distance. Look at that. Look at that. Look at that. It's going to be so much fun. You can see the actual disc. Ah, okay, cool. I will let me click it. Hello. Why won't you click? Click. Thank you. Ooh, that's pretty. Hold on. Here we go. It's a 5-minute long video. Let's play this in the background while we talk about some other things. Tune starting. So the question is, do you guys want to go to tune or you guys want to talk about some more shit? I have more rum to drink, but I digress. Do you want to hear more stories? Who wants to see the picture of the demonic goat fucking George Washington on the Hello Earth Artemis 2 picture? Would you guys like to see that? Because the stage FE 2.0, while I was talking to Dave, Whale Panties went over and started talking to the stage. And Mike was with me and just letting me roll with it and was interjecting when he saw fit. It was perfect. Like that was so much fun. Perfect. That was both there. Then some other one was trying to get Dave's attention and Mike literally just grabbed the guy and took him away. It was, oh God, it was so perfect. Just took him away. It was some baby flirt who was trying to get Dave's attention and Mike was like, oh, let me talk to you, and took him away. And it just left me and Dave there again. It's like if we call it Operation Let's Bake It Baked Potato, it went flawless. Of course we need to see that. Of course. Yes. Let me Nope. Let's do There we go. Speed this up. Oh, look at that. That, my friends, is that's outside that's outside Brisbane, is it not probing time? Or is it? You took a picture of a distant container ship yesterday with my P billion, but I haven't checked it yet. That's exactly what I want to do. Except I want to shoot video to make sure that Mikey sees it's a video. Yeah, just like Santero said, he took out his phone and you could put a house on the ocean. It's so flat. Roger's channels is full of, we're talking about generational thinkers. Like, cutting edge derp. I'm surprised they don't all wear fucking Velcro shoes and have supervision. Oh, look. Wait. Look, the cloud went behind the sun. The cloud went behind the sun. Now it's in front of the sun. There's a hot spot. Okay. So, okay, I got to pull this up because this is a special sort of derpitude. Copium, thank you for the update, by the way, my friend. I appreciate that. Where was this at? This was Whale Panties was nice enough to post it in the Zoo Crew chat on Unfornicated. So here we go. Hello, world, or the devil. You decide. A satanic goat cornholing George Washington. It's a picture book. NASA pic of Earth? Question mark. Or is it the devil? Whale panties, your artwork is perfect. So apparently this is the goat face. I guess this is the eye. This is the horn. I think. Yeah. So the whole thing is the goat. So this is the goat face here. So like this right here is the face, and this is the horn. And then we have the wig of George Washington. I guess this would be his eye, his nose. This is his chin. Anyone got a quarter? No, that's some goddamn Picasso shit right there. You're not lying, Marcus. Okay, so we have George Washington. We have the goat, I think. And this is the goat dong, we think. So his face and horn is up here. This is his body. This is his dong. And then this is... Hold on. There's George Washington right there. So, okay. Right off the Ivory Coast is George Washington. So this is George Washington there. So that's the dong. Fuck. I see it. I don't know about you guys, but I see it. Wasn't quite sure about the goat sex penis part. Whale panties. You deserve an award for your artwork for this year. Somehow or another, I'm gonna have to get something to you. Actually, you know what? Do me a favor. Go to the Unfornicated store. Pick out something for yourself, whether you want a day shirt, coffee mug, or something like that. Whatever you want. Send me an email with the what the item is, like the name of it, or the link to it, and I will send you a coupon for you to redeem, and you can do it not only for the artwork that you see here, but also for the great lunch, having a friend and bodyguard to back me up, and all around a lot of fun hanging out with you and Mike at the same time. Not to mention, you had to listen to this shit, so you deserve something for this because this is fucking gold. But yeah, so thanks to Dave, I have about a year's worth of derp to go through. What else do I have? I found out that there is, I shit you not, there is the world's smartest flat earther, self-proclaimed. Now, okay. So
but I think white dudes have the coolest.
Stop. Shit. Right here. Go to hers. Okay, so Dawn was nice. So Dawn is a college student, very bright, very intelligent, also very funny. And I've talked to, she's been on Whatcast. I've talked to her a few times. She is a great person to talk to. Well, the smartest flat earther is writing a book. And when he talks about the smartest flat earther, in the world. He talks about why he's smart. He has an engineering degree in industrial engineering from Purdue University, which means he had to take physics. I mean, we're talking about Newtonian mechanics, simple shit. But he thinks the world is flat, and we didn't answer on the moon. His big claim to fame is he is building a vacuum tube that's going to allow him to show that a rocket needs a medium to push off of. We all know how that's going to go, but I digress. So he keeps pushing his website. He keeps pushing his book. And in his book is QR codes to go to watch the videos. The videos are really the debunking tools, the claims, as opposed to the book, as I'll show you. So let's pause here for a moment and think. Why would somebody want to direct traffic to a book and also a video? Put in your guesses now. I'll pour myself another drink while I wait. Do 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 do. Now starting to get some answers in. We got Holy Hand Grenade, a grifter. The highest IQ charlatan saying God can be proven, and it's the Christian one. It's kind of like that. He's not. He's actually agnostic. He's not a religion flirt. We'll say grifter. Cheers. Sorry, I want to do a high pour. All right. Yes, grifter, because now he gets views on the videos. Now he gets someone to buy the book. But he's handing out the book to a select few that he thinks are worthy. And people debunked him. So Fuzzy Bear called him out on a bunch of stuff. Fuzzy Bear 2, T-O-O, look him up if you're on TikTok. And Dawn Chorus 3, she was on Whatcast. You definitely need to look her up too. Now, let's hear what she has to say about this book.
Today I would like to take the time to debunk as much as I can of Levi Miller, aka the self-proclaimed smartest flat earther's book, Globe Deconstruction. It is an extremely tough read, but I did it for you, and we're just going to go through some of it together so you don't have to waste your time like I did. The reason it took me not that long to read is because most of the book is literally just pictures like this, of which he gives absolutely no credit for, and I can assume he does not have the licensing rights to, meaning that the majority of this book is just a huge copyright violation, but that's how I was able to read it so quick. I would like it to be noted that there are 584 questions proposed in this book. While I cannot take the time to answer all of them, this is the first one I can answer. He asks, can we 100% prove this to be the moon? The answer is absolutely yes, we can, because we can measure exactly where the moon is and predict where it will eclipse and when it will eclipse. Eclipses obviously only occur during a new moon, which is perfectly predicted on a globe model. And we would also need to figure out what the second body is, which would somehow have to be invisible throughout every other time of the year. This just absolutely makes no sense. Yes, we can absolutely prove that this is the moon.
584 questions he asked. And I'll show you his website in a minute. It's fucking cringe. I wonder if he knew that eclipses only happen on new moon. Because let's put it this way. Listening to this guy talk, and I've listened to a few of his lives, I wonder if he actually graduated. Because he says he's not a practicing engineer, he can't find a job, or doesn't work in the industry, so I guess this is why he's grifting. That's the only thing that comes to mind. The problem is he picked the worst group. He picked a group of unemployable idiots to grift from. So.
Page 21, he randomly just jumps into this Action Labs PhD and accidentally proving space travel to be a hoax after his acknowledgments. What is happening? He also does acknowledgments within the first 10 pages too. What is this? This is like just terrible formatting. But then he says we need to go to page 80 to 83 to debunk this experiment, proving that gas cannot move a syringe in a vacuum chamber, even though the syringe absolutely does move in the vacuum chamber in this video that he's referencing. But then the next page is even crazier, because then he just has as this. Should Australia be this big? What is this? I don't know what this is. I'm also not sure what this is supposed to be showing. I don't know the source. Again, this is likely a stolen image of which he does not have copyrights to, which is a huge civil case just waiting to happen. He then just inserts this picture randomly, which I don't know what this has to do with anything. Thanks, I guess. He claims that flat earth is the most impactful two-word combination in the online community. But what about Me Too, coronavirus lockdown, Taylor Swift, even Quandale Dingle, John Pork? These are all things that have had greater impact in the online community as a whole than flat earth.
I love Dawn's take on this. Me Too, coronavirus lockdown, Taylor Swift, somebody Dingle. That's fucking hilarious.
Completely crazy take. He also then quotes Witspit, which he himself was making fun of, posting like his mugshots in his Antarctica documentary, so I'm confused why you're using it here. He then gives his best evidence for heliocentrism and asks, what other real world observation did I miss that would 100% be exclusive to a curved spinning orbiting Earth? Write them down here. I will go ahead and do that now. Here are 27. You can feel free to pause and zoom in and read that, but then he asks if all of the above claims were exposed as logical misunderstandings, would that be enough to change your mind? If you can prove that every single one of these is like a logical misunderstanding using science and math, and like, sure.
Okay, so the mountain of evidence for heliocentrism. Okay, his mountain of evidence that he lists includes 1, 2, 3, 4, 5, 6, 7. 7 claims is what he thinks is the mountain of evidence for heliocentrism. Boats in the sun disappear bottom first, which is 100% proof of a geometric horizon. No other model can explain this. I'm not sure that's heliocentrism, but that's more of a globe, but okay. Day and night cycles only make sense on a spinning ball. Okay, that's, again, globe, not heliocentrism. All eclipse observations line up perfectly with heliocentrism. Well, finally got one of them. The sun, moon, and planets are spheres, so it makes sense that the Earth would be as well, given space-time curvature. Okay, yeah, I mean, that's logic. Observations of circling 24-hour sun in Antarctica. Funny thing is, he thinks that it was faked. He thinks that a looped video that was an editorial chase is proof of it being fake, and that you can't trust NASA or anything else that's ever been provided. He wants to go down there himself and do it, and he wants someone else to pay for it. I told him that Toon has a challenge for him. He won't take it. Whatcast offered to have him up to talk to Dave McKeegan, and he won't take it. He doesn't want to talk to Dave McKeegan yet. He's working on his vacuum chamber experiment. He's not ready for the big boys yet. Jaron showed up in his chat and he wouldn't bring him up either. Because he's scared. He's got no evidence. He's a douche nozzle. By the way, Dawn's got very small writing, and I don't even know if I can read this without my fucking glasses, but she lists, let's see. Long-range gunnery using hemisphere-dependent Coriolis. True. Circumnavigation distance shrinks towards the poles. True. Did a video on that one, too. Longitude lines converge. True. Meteor rates are higher after local midnight. Let's see. International dateline, sidereal versus solar day, mismatch, global wind, something, fixed latitude, shortening after, oh, fuck me. I need Dawn to send me a screenshot so I can zoom in. Foucault's pendulum. I would also add in phases of Mercury, phases of Venus. I would say that the moons of Jupiter and the periodicity show a heliocentric Earth, because the only other way that works is if the moons are circling Jupiter, which is circling the sun, which is circling the Earth. Make that fucking make sense. But I digress.
Just goes into some like flat earth evidence. This is all like very non-unique. It's been debunked, or at least is like very heavily talked about. Watch literally any flat earth live and you will like see exactly what his points are here. None of these are unique. None of these are groundbreaking. And he also asks question 4 twice.
Fuck.
Again, none of this like flat earth evidence is unique. You can watch like any of like Caleb's videos, Angels of Light, Flat Earth Dave, like they all go through the same stuff, even though he claims to not like these people because he thinks they're smarter than them. I would argue like what you're about to see is evidence that he is indeed not the smartest flat earther. But yeah, all of this is just non-unique. But let's get into the really fun stuff now. Perhaps the most damning evidence is on the next page, page 233, where he lists all of the evidence that makes him, Levi Miller, the smartest flat earther. Okay, maybe
he out because he was literally doxing himself. The only part she left on is that he was an engineering graduate from Purdue, and he says this himself. But
233, where he lists all of the evidence that makes him, Levi Miller, the smartest flat earther. Okay, maybe he was right. Maybe he is indeed the smartest flat earther. Where things get really crazy is around page 246. Mind you, this is a book about globe deconstruction, and now he's asking questions about buildings. These are all stolen photos. He has no context for them, no like explanation of like why this is like globe proof. These are just photos that he stole and did not give copyright for and did not give credit to. How does this prove flat Earth? This is not flat Earth evidence. What is this? And in case you think I'm lying, he doesn't explain any of these images, any of these stolen images. He does not explain anything of it.
Tartaria found, not built. Take your pick.
But you should always verify before blindly accepting claims. Sure, okay. So now we're going to talk about historical.
Verify before accepting. Remember that. The art of historical manipulation. QR codes to videos.
Manipulation. Oh boy, let's see what evidence we have. Oh, it's just more stolen pictures with no explanation. Got it. Okay. Now we're gonna go really off the deep end, because now in the middle of the book he just has a page, evidence of repopulation, where just more stolen pictures of like lots of people at once. What in the world is happening? Now here we go into Civil War cause denial. What he is arguing here is basically that.
Love that one.
That it could be possible. His argument is that it could be possible that the Civil War wasn't fought for the reasons we're told in textbooks. Levi, I challenge you to read the Confederate.
It's a very low bar to cross. So.
States of America, Mississippi secession paper, where they literally say our position is thoroughly identified with the institution of slavery, the greatest material interest in the world. You really think that the Civil War didn't have anything to do with slavery, or at least isn't as much about slavery as we were told? This is ridiculous, and frankly is attempting to erase history that killed millions of African Americans and kept them enslaved for generations. This is
basically what it is.
Absolutely disgusting. Okay, I am about to start crashing out, so I do have to relax a little bit, but this is absolutely disgusting. If you think that the Civil War was fought for any reason other than slavery, check out the Texas Declaration of Secession, the Georgia Declaration of Secession, or the Mississippi Declaration of Secession, which I already read. You can also read speeches by Alexander Stephens. Even looking at the Confederate Constitution, you will see that they explicitly protected and guaranteed the ownership of enslaved human beings. Great, more stolen pictures. What is happening here?
I know the context of these pictures. She doesn't. World's Fair, they're made out of wood and plastic and paper mache and stuff like that for these ornate buildings and things like that, but they're found. But they get taken down right away. I don't fucking understand how the World's Fair has ever proven Tartaria one way or the other, except to say that they point at a building that's for a World's Fair, don't acknowledge as part of the World's Fair, and say it was found, and to come to realize it's made out of plywood and fucking paper mache. But that's Tartaria and lasted decades, supposedly. But whatever.
Literally, what is happening? Geology or meltology? What are we talking about?
We talked about meltology and Vlad and the melting bricks and all that stupid shit. Remember that? That was fun.
What is this red arrow pointing to? What is this? This is insane.
That's actually a Tartarian hotel on the red area, and that's the windows from the upper stories looking out.
He starts to try to prove aliens. What he's showing here are, again, stolen pictures of skulls from the Democratic Republic of the Congo. This is from when the people who lived here practice something that's called lipomo, I'm pretty sure, which is basically like intentional cranial elongation.
Well, Penny said the red arrow is pointing to the goat penis. We finally found it. Yeah, Leo, you're absolutely right. And hand grenade, you might be onto something.
When they would tie cloth around like a baby's malleable skull as to elongate the skull. This is not evidence of like aliens or anything like that. This is just like complete misunderstanding of what we're looking at here. Oh, but certainly this image will prove a flat earth. Certainly this is evidence of flat earth, right? Wrong. Go ahead, read this. He didn't even have the time to debunk all of these images. He just out of nowhere starts showing photos of freaking Atlantis.
Fan also.
All of which have been thoroughly debunked as like being like part of like some secret, like, bro, this was taken on a Honda Civic backup cam. This is the evidence you're providing. What is happening? Okay, made it through. If you guys, oh my gosh, just, I'm so, if you made it to the end of this, just, I'm sorry. I'm sorry that you had to deal with that. This is just nonsense. I can't believe this. Oh my gosh. Thank you for watching to the end. I am so sorry that you had to deal with this. Just, wow.
Oh, by the way, in case you guys didn't notice, I have this is my second account. My second account is, well, you could probably understand what the name is from. Let's see if Stupid Fuck is actually, he's live. Do you all now want to hear Levi be stupid? I know, Holy Angry. Dawn is great. She's absolutely hilarious. She's funny as fuck, and she's pretty smart too. She debunks flat Earth. She's a rip. Let's see what Shape Debate has something to say, shall we? I want you guys to understand this a little bit.
I think you need to listen to Bart Ehrman. Yeah, they created the Trinity to like solve a problem in the Bible because it refers to different things and whatnot. But yeah. But think about it. If the Holy Spirit was real, it should be divine enough.
Like we're on religion today
to at least keep.
Well, I don't really give a shit.
The church's
his
knowledge about flat Earth active. It completely died.
His website is this.
No. People.
Okay. He also has a YouTube channel. I'll show you that in a minute. Let's see. What did I want to find? I wanted to find space travel research. Hold on. And this one. Yes. No, that's not the right one. This one. This is the right one. Now, you guys know my wheelhouse, right? You guys know what I like to do. So let's listen a little bit on the stupidness of what this claim is. Now, this is his question. He said this is his favorite claim about Apollo being wrong. Now, I admit, this is the first I heard of this. So I started doing the math last weekend after I dealt with Dave on Saturday. I learned about this on Friday, and then Sunday, because it was so hot outside and I couldn't do shit, I started doing the math on this particular claim. I don't know what else to tell you. I'll just let it play.
That we have examined the original videos from spacecraft films and that the debunkers themselves acknowledge that these videos are unedited and uncut. Can you explain why, in several instances, the delay between the question and the answer is far short away, and a small error in the angle as if this astronaut were standing in a room next door? Question. Debunkers themselves, in several instances, the delay between the question and the answer is far shorter than it should.
That they're already going to start answering before the end of the of the sound. I mean, they don't know where it's going to end. They could wait, but if they already know the answer, like, hey, Apollo, we want you to head towards that mountain over there. As soon as they start heading mountain, you can start saying Roger, and it's going to overlay. It's not that. Come on, it's like, this is stupid. Like, we're interested in either documented samples or a rake sample there. If you think it looks like so, or a rake sample there. Okay, understand. You didn't need to hear this other part. It did not have any pertinence to the thing, and that's probably why it was less than a second to understand. Or you could have stopped it if you think it's a good area. Okay. By the way, the delay is only 1.5 seconds at most. It's 1.25 seconds. So unless you are trying to time this as this is the celestial thing and be 2.5 seconds, after he said there, that would be probably 2.5 seconds.
Could be if the conversation had truly taken place between the Earth and the Moon. Another aspect of the telecommunications that raises serious questions are the live television broadcasts from the Moon. The first 3 lunar missions, Apollo 11, 12, and 14, had sent some rather poor TV pictures back to Earth.
Yeah, I wonder why
beginning
that was.
with Apollo 15, the technology for the live broadcasts had definitely improved. Not only did the astronauts now have the lunar Jeep called Rover, but they also had a new color camera that was mounted right in the front of the rover. This allowed the public to follow the different operations on the lunar surface on live television. This camera, dubbed Rover TV, was remotely operated by a specialized technician from Houston. To transmit the images back to Earth, the astronauts used a special umbrella-shaped antenna, which was
it was like an umbrella that it folded up, but it's also called a parabolic dish, you dumb fuck.
also mounted on the rover. Obviously, the astronauts could only broadcast live images when the vehicle was stopped between one station and the next, because the umbrella needed to be pointed with great precision towards the Earth before any broadcast could begin. The Earth and the Moon are some 240,000 miles away, and a small error
Now, remember,
in the
this
angle
guy's a
of
flat
sight.
earther, and he's saying this is his evidence. A, it's not his channel, so I don't know why he's trying to get views to another channel. Doesn't make sense. He can't even grift right. And B, he's talking about the moon being 240,000 miles away, and he's saying that A, we didn't go there. B, also he's a flat earther, which means the moon has to be local, apparently. I'm not sure. Because if you're going to invoke this, you have to invoke, okay, yeah, we didn't go to the moon. This was done on the stage or whatever, but you're saying that the distance is still the same. You got to take your pick here.
Would be enough to completely miss the target. From the NASA website, we can read, the high-gain antenna produced a beam tight enough that an adequate TV signal could be received by 85-meter dishes on Earth. This antenna had a nominal gain of 24 decibels in the center, which dropped to 20.5 decibels on a 10
Now,
degrees
this is
cone.
where I started doing the math.
In other words, by increasing the transmission angle, the signal would rapidly degrade. Pointing the antenna with sufficient accuracy was tricky, writes NASA. A preliminary alignment made by sighting along the transmitter mast had to be done carefully. After that, the astronauts carried out a precision pointing by using an optical device mounted directly on the antenna. From NASA's training manual, we read, bore sighting the high-gain antenna to the Earth requires an optical aid, since a full Earth subtends an angle of less than 2 degrees when viewed from the lunar surface. This is the aiming reticle from the optical device. Each square represents an angle of 3 degrees. The high-gain antenna pointing, states NASA, must remain within 2.5 degrees of Earth. This occurs when the Earth's image is within the bullseye of the optical sight. The video signal will degrade extremely rapidly beyond that point due to the very narrow antenna
They already gave us the
radiation
radiation
pattern.
pattern that says that when it goes to plus or minus 5 degrees, it goes down by 3 dB. But again, we're only talking about half of the equation here.
In other words, even a misalignment of a couple of degrees in pointing the antenna would have resulted in the Earth target being missed.
Wait.
We must, in pointing the antenna, would have resulted in the Earth target
That's not
being
how
missed.
fucking radio works. It's not a goddamn string. It would drop the signal strength. So yeah, this is what I did. I started planning this. I started doing the math. I started doing the link budget. I started actually doing what this idiot can't fucking do, and the idiot this video can't fucking do, and that's actually understand how radio works. I can also not only build the link budget, find out whether or not it was close to not being closed or not. This is only part of it, because this is where they say the problem is.
We must keep in mind that both the TV camera and the transmitting antenna are mounted on the rover, which means that any oscillation of the camera implies an equal oscillation of the antenna. This is a well-known problem for television crews who broadcast images via satellite. Their mobile units are normally equipped with special pods that are extended once the transmitting vehicle is in position in order to avoid oscillations of any kind. And on Earth, the margin of error is much larger than that of a broadcast from the Moon, since the distance from the geostationary satellites on Earth is much shorter than the distance between the Earth and the Moon. It is therefore evident that in order to maintain the live connection with the Earth, the rover needed to remain practically still for the entire duration of the broadcast. What we have instead is a series of situations in which the astronauts violently shake the rover, and thus also the antenna, without the broadcast ever breaking down.
Now, I'm going to have to do frame counting and use the horizon and everything else to find out what the degree differences of that shake was. Here's the thing. That shake was downwards, not left or right. So what we need to know is what the receiving station was. Was it Parks? Was it Goldstone? Was it Honeysuckle? So we know what antenna it was pointed at. And we also need to know what was the orientation of this antenna at this time. Was it straight up and down? Was it straight horizontal? Was it somewhere in between? Before you can sit there and say, oh, it would have missed Earth. Because it wouldn't have. Because I guarantee you that was less than 5 degrees. Yes, radio spreads out over distance. This is not, I mean, like, this is like basic knowledge. But yet they seem to think that that jostle right there, that up and down jostle was enough that it should have caused the TV to misalign, lose broadcast, and then come back, or at least cause static or something else. This is the amount of stupid we deal with. Yeah, exactly. But holy hand grenade, here's the problem. You can't say because the feed didn't go out, therefore it worked. Supposedly the moon landing never happened, so therefore this is evidence that it wouldn't have happened, because had that done that, it would have caused the signal to not reach Earth, therefore moon landing fake. These are the fucking gymnastics they mentally have to go through to deny anything. Yes, you can.
It happens when one of the astronauts touches the rover to drop or retrieve some tools. In order to...
Now, here's the thing, too, and in this case specifically, remember, the camera's remote, it is remotely controlled. It's not controlled by anybody in the astronaut. It has a pan and tilt. So watch this. Does the actual rover shake before the camera starts moving?
The astronauts touches the rover to drop or retrieve some tools. In 85-meter dishes on Earth. Preliminary when what we have, and thus also tools. Happens when one of the astronauts breaking down.
Okay, so watch it when it goes to the other thing and tell me.
This usually happens when one of the astronauts touches the rover to drop or retrieve some tools. In order to assess the actual oscillations, one needs to look at how much the line of the horizon in the background moves up and down.
Which is what I'm going to do. So that'll be a video too. Exactly, Marcus. I already started doing the math on it. And that's not counting, like, if it was going to Parks, that overhead it had over a 9 dB overhead to begin with. So if it lost 3 dB, if it had 11 dB overhead to begin with, so or 12. If it lost that 2.5, 3 dB on the side lobe, it was still enough to where it had 9 dB overhead on top of that. It may have been marginal for Goldstone and may have been marginal for Honeysuckle, but not Parks. Which one was receiving during this time? We don't know. Which one, what was the actual percentage change? Don't know yet. I got to analyze the fucking frame by frame on this stupid shit. I digress. I'll do the math on it. I'll do a video on it. But generally speaking, this guy's a fucking idiot. And that's where we're going to land. Yeah. For those that don't know, it's like, that's Parks. So yeah. That's Goldstone. They don't actually account for anything on the receive side at all because they're idiots. Because they have a conclusion and they go looking for it. So, don't know what to tell you. It's still in the sheep paddock. I would love to go to Parks and do a tour and walk around and take a look. I'd also like to do it at Montreal with Marcus, even though he already did it for the channel. I'd like to go out to Goldstone. I've seen the Goldstone one, but haven't toured it. You can see the Goldstone from, here's an idea, miles away. Yeah, it's not an issue at all, Leo. That's the problem. They're making it an issue. But however, because they're making an issue, making it a claim, and he thinks that this is the best of the 3 segments as far as what it proves, and said so on his live. I wish I recorded it. So now I'm going to have to do something like, make a video out of it and prove that he's an idiot. But the best part is I get to spend the first 5 minutes of the video making fun of him. And then I get to finish the video making fun of him again. So I digress. Yeah, I know it's got an E in there. Give me a break. I'm not paying attention. First thing, everyone is like them and in the basement, dumb as rocks. Right. So hold on. Let me explain something. I was listening to a live. It was like, I don't know, fucking 2 o'clock in the morning. And I believe I think it was Saturday night. After we got back from Stanford, maybe, I think. And he was talking to a guy who teaches. He's a professor. And supposedly Levi Miller, who is an industrial engineer, took engineering at Purdue University, had to be dog walked through F equals MA. And I don't mean like dog walked like, like I'm talking about like explaining a force, explaining mass, explaining acceleration. When I mean dog walked, I'm talking about a 10-minute conversation of just that equation and what it means. But yet this guy is an engineer. I don't fucking think so. Probing, I guess that means I gotta have to go sooner rather than later then, huh? Yeah, I want to walk around the outside of the building. I want to walk around the inside of the building. I want to see like everything and just video it all. Yeah, it's high school stuff. I know. The fact he got dog walked on it and had to be explained to it like he was a middle schooler in a high school class was. There was nothing I could throw. All I could do was just scream into a pillow repeatedly and hope I didn't wake anybody up. It was beyond fucking painful. Which explains why he's a flat earther. That's all I got to say. All right, all. I think we covered everything. Yeah, if you guys got ideas for Cape May, drop me a line. If you got some ideas, any other video ideas, drop me a line. I'll be doing one on the high gain antenna and the rover. I have 8 different fucking scripts to record. I'll be honest, by the time I get done with work and dealing with people on conference calls and the stupid I got to deal with as I'm integrating in a new company, the last thing I want to do is sit in front of a fucking camera and record and then listen to myself talk as I edit. I do that all day long. It's not what I want to do. However, I know that you guys come here and people expect videos, so I need to do them if I want to help grow the channel. So this is also why I want to do the Cape May observations, because it's going to force me to do actual videos. And the great thing is, maybe I'll start getting dumbasses in my comment section that helps rise the engagement, and they can come derp out in public. Oh, one of the guys you know is a pilot? Ooh, probing. Sounds like we need to go get some rum and go make a side trip. Holy Hand Grenade says, "We love that you do, and it's awesome." Thank you, Holy Hand Grenade. I'm, I hope my engineering shit doesn't go too crazy. I'm trying to separate concepts from the actual math. But there's a few videos coming up that I need to actually do an irresponsible number of math, and I'm trying to find a way to make it interesting for some lay people besides just watching me write equations and fill out a spreadsheet to show that people are dumb. And primarily, I'm going to use it to try to get that $1,000 out of Jack, but I know it won't happen. So Jack Trax can, he can suck a bag of dicks, or eat a bag of dicks, actually. And him and his little paranoia fantasies about men in black showing up at his doorstep. But you know what? Hey, that's a great segue. Mental health it should be a priority for all of us. And, there's nothing wrong with seeking professional help if you need it. But don't just take your own word for it and self-diagnose. You really should, even if it's ever been questioned by your loved ones, or if it seems a little off, maybe go see somebody. Get a professional opinion. That's all I got to say to that. That's all I got. I don't know if you all got anything you guys want to talk about or not. Marcus brought up a valid point. If I'm going to Cape May, I should visit the InfoAge site, which is it's the former site of the Project Diana antenna. Actually, I showed a video of that. Let me show it again. It's really, really, really cool. Especially if you could actually spell YouTube correctly, Dan. Oh wait, I could have just, no, well, wait. Cat meow to the moon. What was it called? The InfoAge? Yeah, InfoAge, New Jersey. What was her name? I don't want shorts, fucker. No, I want videos. Ooh, wait, no, watch videos. No, that's not what I wanted. Videos. No. She was standing in front of the antenna and she made a comment like sending my cat to the moon. I should probably play a song while I'm doing this because it's dumb. Here it is. Here we go.
A2 OMA Kilo Delta 2, Oscar Mike Alpha at the InfoAge Space Exploration Center, sending the first cat meow to the moon. And Shay has traveled 500,000 miles from the Earth to the moon.
So this woman literally came over and did a nice little thing about InfoAge, walked around the site. This is the site of the original moon bounce for ICBM testing and radar. That was our first actual verification of distance to the moon. It was done in 1948 with Project Diana at the exact same site that I think Marconi was at too, if I remember correctly, but I might be wrong. But at least it was a site of Project Diana. It's still there, and I know you can still go to it. And Marcus, that is one hell of a suggestion, and I might have to do that. So all being said, it's been great having you guys all. If you guys got nothing else, I'll go kick you guys over to the moon. Is MC Toon playing? Yes, he is. Okay. I'm going to do my first raid of... I'm going to do my first raid. Oh, I didn't even show you guys the video. I'm fucking sorry. Knew I was going to do something like that.
A2 OMA Kilo Delta 2, Oscar Mike Alpha.
Shut up.
A2 OMA.
So, here, fucking transition it. There we go. Here is the actual video right here. Sarana Rotgard, she sent her cat to the moon. It was done 5 years ago from the InfoAge Center. And we've played that on here before. If you're not, it's pretty cool. They talk about the distance to the moon. They talk about some of the history. They talk about what it's going to do. And she literally bounces the cat meow off the moon. You can hear it come back 2 seconds later. It's pretty cool. So I'm going to send you guys all over to Tune. I have to go into my page and set up the link real quick. Please bear with me. Don't go on your own. I wanted to actually raid Tune for a change because it's funny to do that. Because it'll be the first time it actually shows up that way. So I think it'll be pretty cool. Let me go to my lives. Let me go to this. And how do I do this? Customization, maybe? Redirect. Here we go. Add. We'll do that. And we're going to save it. All right, cool. Now let's see if it works. It'll be the first time he's ever been. You guys are probably already there in this chat, so it's going to be like 5 people that show up. But hey, let me just say thank you for the super chats. Thank you for the memberships. Thank you for being here and hanging out and listening to me drone on and on. Hopefully, by some weird chance, you may have learned something today. That's on me. I'm sorry. Maybe next time I won't teach anything. Fat chance. But yeah, if you did learn something, my apologies. That's on me. But next time, we'll see. So as always, again, thank you all for being here. Thank you for all the contributions, whether they were jokes, whether they were comments, whether they're questions, whether they're memberships, whether they were anything at all having to do with interaction. I thank you very much. This channel would not be here without you guys. So thank you. Have fun over at Tunes. I will see you guys over there. In the meantime, stay uncensored, stay unapologetic, and stay unfornicated.